Hello, everybody, and welcome to another episode of Discussing a Murder Extras. And in today, we're doing a live demonstration. Without any further ado, let's get to the panel today. Who's joining me? Kellie and Dr. Silkman. I don't even know what to do because Big Jeff's not here. I'm kind of fumbling. I don't know who to go to first. He's my go-to guy, so I'm like driving without a clutch here. Maybe Kellie, I'd like to introduce you first today, just because you're kind of the one running the experiments.
Sure. Good morning,
It's kind of
everybody.
your show today.
Well, good morning, everybody. I'm just going to make this quick so we can get Dr. Silkman to say his good mornings and such, so then we can get straight into it. So, thank you everyone for joining. Bear with us today, with me because it's a little bit to run through. I'm glad that I have Dr. Silkman here on the panel because he can help me break down what you guys are about to see. And again, thank you, Jeff Jones, for giving us the platform to host this. Over to you, Dr. Silkman.
Welcome, everyone, and Jeff and Kellie and everyone in chat. It's really great to be here. And it's my birthday today. And apparently, Jeff, you're a Gemini as well. Good to be here.
Happy birthday, Dr. Silkman.
Happy
Thank you very
birthday, Silky.
Thank you.
It's another trip around the sun, and every one of those is one better than the one before.
Correct.
And you gotta wear that with a sense of pride every time you get around again. So congratulations on that.
Thank
I
you so much.
feel as well. Happy. My birthday's on Sunday. I let the cat out of the bag because I bought a new golf club, and I had to show everybody because that's who I am. I'm a show and tell kind of guy. And that's how we found out today that it was your birthday. And
Correct.
so
Correct. And
it's a great day to have alive.
And what better birthday present than talking a bit about murder, dismemberment, cremation, and blood? You can't get any.
Oh, and Anthony D. Happy birthday, Anthony D. He's also a Gemini on Saturday. So it's like the birthday episode, I guess. Birthday live.
It's the birthday.
Enough of the birthday talk. We need another B word, and that's blood. And so let's transition into the blood talk. Kellie, I know that there's been some behind the scenes talk about getting these experiments and explaining some things that we didn't get to yesterday in the premiere that you really felt like you kind of had something to share. Without any further ado, I will throw up your.
I was just going to say, just not yet. I just wanted to kind of bring up some things from the previous podcast and then kind of go into it. Just want to outline a few things because there was a mistake on my behalf that I misquoted something, so I really want to clear that up. And I just want to kind of touch base on a few little bits as well, if that's okay with you guys.
Yep.
Okay, so firstly, I misquoted or misspoke yesterday or last week when it premiered yesterday. When I did the experiments, I was using saline to do my presumptive tests, and I was using distilled water. I can't believe I was calling it stealing, whatever the hell I was saying. That kind of goes into the part that Jeff Jones had to. There is a bit of that presentation that got edited out, which you guys will all understand very shortly because I'm about to show you guys behind the scenes of what happened. So I just wanted to clear that up because I think that's really important because there is a significant difference between saline, tap water, and distilled water. Distilled water is has a different percentage in salt, which alters the blood, and the saline itself, it kind of does the opposite. It more flushes it. It lifts it as a watery substance versus rehydrating it. That's what the salt percentage does in the distilled water. So I just wanted to clear that up. The next thing I wanted to clear up is, and it's a fair one to do. Crockett wrote a message, left a comment on the previous podcast, number 17, and said, how do we actually know that the pictures were taken not in situ in terms of the ignition stain? And I wrote back Groffy's testimony ? Because I've read the testimony and it has always implied that was the order. In fairness to his question and his comment, he's kind of right. There isn't any actual proof or admittance that is the order it actually happened. It's just been assumed by us all because of our perceptive of when we've read it, and we've kind of gone, oh, that's what he done. And Dr. Silkman made another great point. You can tell that it has been, it looks like it has had saline to it, because you can see that it's been not watered down, but that there has been diluted. That's the perfect word. So correct. I just wanted to put that out there as well, because Crockett made a great comment. We don't want misinformation out there, and we don't want to. And we've learnt that throughout this case. We've heard rumours that Teresa slept with Scott B, but has that ever been proven on her side, rather than just it coming from Bradley Checks's mouth? So little things like that, I think we should put out there, that it is something that has not been confirmed. Another interesting thing. We saw a comment about a pregnancy test in terms of the dropper and stuff. That dropper I use actually was from a pregnancy test. So me and Jeff Jones just had a giggle about that, because that was part of the bit that he edited out because of what had happened. So without further ado, let's get into that. If you want to swap screens now, Jeff. Okay. So what I'm going to show you guys today, I thought it was only fair. These are part of my experiments. There's not, like I said, I siphoned through a few the other day, and I wanted to parallel what I've showed you guys so far. I've showed you a lot of EDTA stuff live, randomly. It was not a planned experiment. I saw an opportunity when we did the podcast, and I took it. But then when I was watching it yesterday, I realized in the premiere, I need to find the balance. We need balance. And I'm always projecting that balance, and fairness. So I thought it's only fair that I give you that. And that comes in the form of fresh blood. So I'm not going to go live right now and take fresh blood from myself, because one, I don't have a syringe. Two, I'm highly anemic at the moment. And three, why would I do it again when I've already done the hard work? And now it's time just to share with you guys a little bit that I was working on for as long as I did a few years ago. So what I'm going to do first is I'm going to show you guys a picture. And I want you guys to really, maybe if it wants to work. Hang on a sec. I'm not sure it's coming. Let me know when you guys can see it.
Yep.
Yeah, okay, so this one's pretty self-explanatory. I try to make it as simple as I can. So on the left side, you have I wrote ETA. I forgot the D. EDTA blood. That was after 7 minutes. As you can see, it was still in liquid form. And I had just dropped it. I wanted to start timing it to see how long it was drying. On the right side is my fresh blood. In 2 minutes and 47 seconds, look at that. It had crystallized. Dr. Silkman, would you like to explain, if you are able to, why that would be in that manner?
Yeah, and that's actually quite stunning, the little comparison that you did there, Kelly. And so if you look at the EDTA blood, we know that when you add EDTA is an anticoagulant, right? So therefore it binds to ions like calcium. And calcium is very important for the clotting cascade. If you add EDTA, your blood is going to remain in the liquid form, right? Now, that's incredible, because if you have a look at the right-hand side, your fresh blood, you can see that the clotting cascade has started to work, right? So that means that in your fresh blood, there is no EDTA. The clotting mechanism has started to commence. And you can see that if you are able to have a look at that under a microscope, you'll see that there'll be cross-linking taking place. You're starting to form a soft clot, right? And so that's remarkable, because you can clearly see the difference between the liquid blood, which is the blood that's got EDTA, as compared to the blood that's fresh and it's started to clot, right? There is a big difference. Yeah, that's dramatic. That's dramatic.
Yeah. So and when you see the my fresh blood, you see like a little drip, about a bit of drip of distilled water about to hit it. You can see it ready to come onto it, because this was captured from a video, and this experiment that I did was when I first got my blood, and I did this one in my bathroom because I wanted to do one. I wanted to find a balance. I had done a lot of study, a lot of research, and when I worked with the consultants on what plan we were going to take and the structure of how I was going to conduct these experiments, I wanted to also do one on a natural basis where there was no planning and just drop it and let natural elements take over. And that's this one. This one has no controlled lighting. It has no controlled temperature. It has no controlled well, the timing's the only one, because I wanted to do a 5 minutes like rotation of both capturing. But yeah, so I just wanted this one is a non-controlled experiment. It was literally just a natural drops, and I walked away, came back in a few minutes and seen what was going on. Oh, and the other thing was, it was like a bit warm that day. This was done in December, and December in Australia is
hot.
Very hot. It's summer. So that's why when I say temperature control in experiments, it's really, really, really important. And that you'll see that as I go along, because you see my fresh blood here, it took 2 minutes and 47 seconds, uncontrolled, with just the natural elements of the temperature and stuff, versus what you're about to see with my fresh blood when it is under the right temperature control, because I went back to the Wisconsin weather in 2005 of that week, and I tried to control it as cool as I could in my bathroom, which, like I said, I have a special air conditioning that has zones in my home, so I can control every zone. So basically, I just wanted to show that picture to start it off, and then the next bit I wanted to go to. Okay, so the next bit
Kellie,
is a little, yes.
Kellie, can I just make the point? That's a
Sure.
non-absorbent surface that you've put the blood
That's
on.
Correct.
That's important too.
It's very important.
It's not absorbing into anything. It's sitting on the surface, and look at the way it's reacting. That's
exactly.
amazing.
And I'm so glad you got there, Silkman, for me, because like I've got my notes beside me, and it's a lot to get through. But that is the other factor of when I did my experiments, was I had to consider surfaces. And like I said in the previous podcast, I had to take into consideration colors. And I know that sounds really bizarre, but you guys have to trust me on that. I will provide that later throughout more videos that I'm going to show, but color makes a big impact, because the color, you're dropping blood on a certain color charts, warm colors, light colors, soft colors, and then the lighting. And once you introduce the lighting to the colors, everything changes again. So these are everything I had to take into consideration. The only thing that I didn't fail with, but the only thing that I had problems with in terms of the experiment and getting it as authentic as I could in terms of Stephen's bathroom sink, was the sink itself. I don't have his sink. So he had an older, like a porcelain sink. It looks like a more of a plasticky kind of sink, like the olden day ones that we would call older days because of the Australians. That's what you'd find in the olden homes. My home is very modern, so I have the ceramic type. So that unfortunately is the only thing that I have to say straight away, that was the only part that I wasn't able to create,
reproduce. But it's still not porous, so
you should have, as long as the surfaces are both they both have that surface that it doesn't absorb, and that's what we were able to do, because that's the point of the blood, is making sure that things don't absorb. So the next one I'm going to show you guys, I don't know if I should tell you guys the embarrassing behind the scenes story now, or leave that to the second. I think I'll get onto it now, Jeff Jones. No one. A bit of a disclaimer before I show you this video. No children were hurt in the making of this video, and well, the only thing that could have been hurt was his feelings. And I hope that I'm reaching out to all the mothers when I say this, and especially to all the people that have had mothers that have become almost Italian-like, because I had a bit of a situation the other day. So when we were, doing our podcast, and we were, we weren't live, we were pre-recording, and I was as you can guys see, I was in a bathroom, but I was in my children's bathroom because we have 2 in the house. And when I was sitting on the floor, I had the door closed, and it was getting close time for my children to go to school. My husband was in the house, and I just assumed that he would be taking the kids to school. Everyone knew I was pre-recording. They know the days I do it. It's the day they know they can't talk to me. So I'm sitting on the floor, and the door swings open, and it's my going on 13-year-old son. But the attitude is real and raw right now. And he looks down at me, and he just begins to talk to me. And I'm looking at him like, and while he was talking to me, I was actually mid-sentence talking in the podcast, showing an experiment. And I'm like, excuse me, can you hop out for a minute? And he still kept going, and he kept going, and he was going on like, you need to take us. And I'm looking at him, and I'm going, mate, get out. And I'm trying to mute to basically say get out. But unfortunately, because I was in mid-experiment, I just reacted instinctively, and I basically threw the dropper at my son's forehead.
Oh, no.
And as you guys know, what was in that dropper?
Blood.
It was my dead blood.
Your blood. Well, it's half his blood, right? At least half of that, matches his blood. So
I was like, I just was like, get out. And as I went like that, it flew out my hand and hit him in the forehead, and he went really quiet. I quickly muted, and I was like, get out. And all of a sudden I felt it getting flung back at my head. So I got it thrown back, and he walked out going, I can't believe you did that. That's disgusting.
But we did get some scientific data, though, I think, out of this, didn't we?
Well, so the point, I needed to kind of go back to that, because what then happened was, husband was like, oh my God, I heard him in the background going, did you just go into the bathroom when your mum's on a podcast? He's like, yeah, she bloody threw blood at me, Dad. It's disgusting. And then Brennan's like, well, mate, be glad that was a warning, because if it was, she's basically saying to you that she's running out of blood. If you don't get out of that bathroom, she'll be using yours next. So my son started running into the car. And anyway, so when Big Jeff and Dr. Silkman had to leave after the podcast, I went back I was carrying around my laptop, and I was cleaning it up, because obviously you guys saw where the blood was. And as I was walking out, I went, oh my God, Jeff Jones, you're not going to believe this. And I quickly grabbed my phone, and I started to record, because what had happened was, without me even realizing, when I threw the blood at my son, I got a cast off splatter.
Hey.
Without even realizing it happened. Because when it hit his forehead, it splattered out. So Jeff Jones goes, shit, holy shit, record it, because I had went live on my camera to show him. I walked him through it. I'm like, holy shit. And he's like, no, grab it and record it. We need to show this, because this is something interesting, because it's a natural pattern. You didn't try to create it. It was
that's why I think it's exactly.
Yeah. So
you try to do it, and that makes it even better, right?
Yeah.
It's organic.
So
right.
Yeah. So what you're saying here is I'm showing how I was sitting on the floor. The door is open. He was standing just in front of the door, as you guys can see there. There's the door. He was standing around here. You'll see his height, because have a go at this. I'll let it run through, and then we'll go back. I'll let you guys just see it naturally, and then we'll go back and break it down. I turn on the light to give some more lighting, and then you can see, look at the blood splatter, how it goes up because I was sitting down, and the tail.
Yep.
Can you go back at that part of, like, just toggle back a little bit and then kind of run through that? Yeah, like that. Stop it on that one. 1 second.
Okay, let me go back a little bit. Okay, so this is me approaching the door.
Yeah, okay, now I can see that.
There, that's probably like the level of his head. So it's bounced off, and then you've got a drip there, and then because I was sitting down, you can see where look how it's gone up as it's hit his forehead, and it's gone up. It's casted.
You're aiming up, right?
Yeah, because I was sitting down and he was above me. So there you go. You guys can see the tails of the splatter. Again, it just thought it would be interesting to capture because, as embarrassing as it is to say, well, how I got there, it is what it is. And I thought it would be an idea to capture it. So let me just run through it again. And then again, you see it goes all the way down. And look at that one. That's a pretty defined tail there where it's hit and then it's casted off because that was the direction that it was being thrown in. So I just wanted to, as embarrassing as
it's really helpful for us to understand, like, a little bit better how blood moves, how its physical attribute, when it lands on stuff, what does it do? And how hard would you say you weren't actually trying to hurt him, right? You were just trying to, like...
Oh, God, no. It was literally, as embarrassing as it was just an instinct. Like, and when he came home that afternoon, I said, you didn't get any blood on you, did you? He goes, no, I didn't. And he goes, but that wasn't cool, Mum. That was disgusting and it stunk. And I was like, I know, mate. But I said it was, and I said to him, hey, be grateful, mate. I used to have whatever my mum had laying around, whether it was a shoe, whether it was a coat hanger, whether it was a belt.
Vacuum cleaner.
You got, and I just threw it because it was an instinct, because you just weren't getting the answer, like the understanding of get out. My mum used to chase me around with the objects until I learned. So be grateful, mate. And he kind of giggled and we laughed it off. But yeah, so that was that's where
instinct. I think everybody can understand that.
It was, and that it was literally.
But the reason I ask is, like, how hard did you, like, how hard did you throw it? Like, what was the velocity? Like, would you say, like, as hard as you throw a frisbee or as hard as you throw a pen across the room?
Less. I literally, in fairness, the easiest way to explain it was, although I threw it, it basically slipped out my hand because I was like, get out. And I used my hand to basically signal, get out, like walk out. And as I did that, I just let go. But it wasn't hard. It was just like, get out. And out it came, hit his forehead, and then that cast off happened. So, yeah, so that's basically, so yeah, I don't know how else to explain it. I was a bit hesitant to show it, but then it's all in the name of science and experiments.
Well, the comment section, they are making a similarity in the comment section when they're saying, was it back into the left?
Oh God, don't go there, Jeff. Don't go there. Now you're going to say that Kelly was on the grassy knoll, right?
Hey, go back. It looked like a grassy little shower mat there. So, all right. Well, as we progress through to the next thing, what do you got for us?
So the next one, I wanted to go back to. I chose these ones because I wanted like I said, I wanted the parallel. And I wanted the balance. So I showed you guys live the difference between rehydrating EDTA blood and then I thought, okay, now it's fair. You guys see me trying with fresh blood. So what I did here was this is 2 videos that I edited into one, so it was more of a comparison. This was part of my experiment about a year ago. This was the EDTA blood. I chose this one first just to refresh everyone's mind from the podcast yesterday. So this is EDTA blood. Now this EDTA blood had been left for a lot longer. What you guys saw on the podcast yesterday was maybe 45 minutes to an hour, and I was able to produce it to a liquid form sense of blood. So This one had been sitting, I believe, for a few hours. I started it at 10:30 when I looked at my timestamps on the video, and as you can see here, I believe it's like 12:55. So it had been going for almost 3 hours. Had been drying, and as you can see, this stain was absolutely crusted. It was at stage 5. So as you can see, I wrote here the blood was in cycle 5, which is your dry, cracked, and flaky stage, because it had been sitting there for hours. That one was in the video. I had only put that there a little bit previous, so it hadn't been there as long, but it was there for an hour or two, but just not as long as the main one. Again, I just wanted to show the contrast of how dry it was. I wrote here the EDTA stain was in between cycle 4 and 5. It was able to be flaked, but it was just dry. So it wasn't jelly, it wasn't wet, it wasn't crusty, it was just dry. But
How
it was
many
able
hours
to
was
be
that
flaked.
again?
Pardon?
How many hours again was this one?
This one was about, I'm going to say, probably around 45 minutes to an hour less than the one you just saw.
Okay.
So I just kind of show everyone that I had at that stage grabbed some distilled water. This is when I was using the correct stuff, and I went, let's rehydrate. So as you guys can see here, I'm just going to pause it quickly. You guys can see this is crystallized like flakes. This is absolutely at the last stage of blood. You cannot do anything with it because it's completely dried up. So
desiccated.
Yeah, desiccated. Yep. So I'm adding my distilled water to it. Excuse me. And you guys have already basically seen it from the podcast, but I just recreated it. That's how come I did it the other day, because I already knew what the results were going to be. I've already tested it. I've already tried it. And as you guys are seeing right now, I'm able to do it even on drier cycles. So
how far were you able to go? All the way to flaky type blood, EDTA blood,
so
all the way to flakes?
All the way. So the cycle, so there's 5 cycles of blood.
Right.
Again, that's a bit of that was going to be more into like a discussion when you break down every video that I did and like a proper podcast. It's a lot to digest, but there's 5 stages of blood, and this one in the EDTA was at its last stage. You couldn't go anywhere further with it because it was at it was crystallized, it was flaky, it was gone. So I added my distilled water. Here I just squeeze out the excess because I wanted to suck up what I could. And like I said, you guys can always go back and watch the video again and watch and pause it to the exact moment that it was so, as you can see, that was my experiments still going. I do a bit of a shake. Now I wrote here, shake it to mix it, and let's drop it to look at the texture and color. So there you go. If you guys can see that.
I noticed that little off that you tried to make 1 or 2 drops, but I see 1, 2, 3, 4, 5, maybe even 6 peripheral drops. I think that's kind of an interesting indication there, because it shows that it's not really easy to drop just 1 drop. Sometimes you get a little cast off, or I don't know what you want to call that. A little.
It is, but you got to remember, this was rehydrated. This isn't liquid. This isn't straight liquid blood. This is rehydrated. And I think this will be a discussion that we'll get into after I've just shown this, and why I wanted to see. For me, I don't believe. Listen, I'm just going to finish this, and then I think me and Dr. Silkman will kind of get into it, because what it's about to show. So now we're going to my fresh blood. So you guys just saw what it looks like when you do EDTA. So fresh blood. This was straight from my left arm. It had been in the syringe for only about 5 to 10 minutes. I didn't go back and check the exact time. I just knew that in total, when I did these experiments, I had a 15-minute window period, and you can see why in a minute. On the top of it, it starts, or I'll just let you watch it. So as you can see, I'm in the video. I muted it because I knew I was going to talk over it today, so I didn't want to have two voices. So I did mute it so we could talk over it. That was me just explaining that this is fresh. I have to move really fast, and I had just taken it out of my arm, my left intravenously, and I'm about to drop it. As you can see, you see the flakes, not the flakes, the drops. And I did further experiments with the rest. So I just I cut the video short just to kind of capture where I was going with it. So I let it sit for 5 to 10 minutes and I come back. Now let's rehydrate fresh blood. I got my distilled water. So I added a bit of salt to it. That's the percentage of salt to see what could happen. As you can see, with everything that me and Dr. Silkman have been trying to explain to everyone about fresh blood, it doesn't break down. It's at and this is at stage 2. It's only tacky. It's coagulated because it coagulates straight away, but it's only in stage 2. It's not dry. It's not, and theoretically, if someone did take blood from a sink, you would expect it to be probably in this form, because it's not enough to be completely dry, but it's enough to be, the coagulation would have been past that liquid stage. It would have already started to gel-like. And then as you see, visibly, the color and texture has changed. It's no longer blood. Have a look at that.
I have a quick question that, I think either of you could answer. What is the cellular makeup that makes it congeal like that? What are we seeing? Like we know that it clots, but what is actually happening?
Well, blood is a complex mixture, right? Blood actually is a tissue. And when you're looking at when Kellie took out some blood from her arm, that's called whole blood, right? And it's composed predominantly of red blood cells. But also inside that mixture, you've got probably about 90% fluid. You've got white blood cells, you've got platelets, and you've also got proteins. So what happens is your body knows when you expose the blood to air, for example, or you damage a blood vessel, it undergoes a biochemical reaction. It basically tries to prevent you from bleeding to death, right? So normally you don't expect to see blood on the surface of your skin, right? It means that something has happened. You've got a cut. So what happens is there's a biological reaction that takes place, and it forms cross-linking, right? There are all these different proteins, prothrombin, thrombin, whole heap of other proteins that form cross-linking. So the whole idea that what you want to do is form a plug, right? Say you've got a cut on the surface of your skin, you want to form a plug to prevent further blood exiting your skin. So here, what Kellie has demonstrated by dropping fresh blood onto the sink, there's a biochemical reaction that's taking place, and you're getting formation of a clot. So it's a biological process. There are proteins which are forming cross-linking. And you've also got platelets as well, which are also involved in the clotting process. That's not reversible unless you add certain enzymes to it to break down the protein bonds and cross-linking. So that's a permanent thing. So when Kellie added water, distilled water, she diluted out the sample, and hence you got a little bit of the redness still left in that tube. But the predominant amount of the blood has now started to form a clot, and you can't reverse that, right? Because it's a biological process and it involves cross-linking. And there are two forms. There's a soft clot and a hard clot. A hard clot is when you get that real crusty bit. If you've ever cut yourself, in a couple of hours' time, it forms that crust. It forms like a protective barrier. That prevents further blood loss. So this is a very elegant experiment that shows within a short amount of time, you get the formation of a clot, very hard to reverse back into liquid blood.
Okay, I just want a follow-up question right there, and I apologize to slow this down, but then what then what does the anticoagulant, the EDTA, how does that have an effect on those proteins and those making cross connections? Is it
It doesn't
preventing
it doesn't happen. It doesn't happen.
Okay.
So with blood clotting, I actually did a presentation on this. There are two different types of blood clotting pathways, extrinsic and intrinsic. And they all come down together with factor X. Factor X is a common pathway where you form clots. If you add EDTA, EDTA chelates or binds to calcium. And the calcium is important in triggering off the cascade for blood clotting. So if you add EDTA to the blood, it chelates or binds to the calcium. You're not going to get any cross-linking. You're not going to get any clotting, which means that your blood remains in liquid form. It's that simple. It's that simple. So the clotting proteins,
maybe to you.
The clotting proteins are there, but they don't work, right? So here's the important thing. In your blood right now, it's a fight to keep your blood fluid or to clot it, right? All it takes is one trigger and you've clotted your blood. So it's a very delicate biological process. EDTA prevents the blood from clotting, from coagulating. Correct.
Awesome. Thanks, Dr. Silkman. So as you can see on this second drip, this was, you can see it's gel-like. It's formed a clot. I'm trying to soak it up. Now, I wanted to do something different with this one because, as you can see, the clot there. I used distilled water on the first drop because that is the method. If you're in like a laboratory or whatever, they would use like distilled water and you would use a ratio. So it goes on the, again, it gets technical, but if you have a certain measurement of a drip, there is a ratio of how much distilled water you're meant to put to it. So a 1 drop to equal so many mils of blood. So I only had put 1 drip of distilled water with the first stain you see. Now the second one, I knew that when I did this experiment, you got to remember this experiment was based on the sink, the bathroom sink. This experiment was a controlled experiment. I had the temperature cool, everything was freezing. I had it all controlled. So what I did with this one is I thought, I'm going to be careful how I say this. I'm not going to say, let's say the sink theory is plausible right now. We're considering that's how I did this experiment. Let's see if I would do it. I wasn't expecting someone, if they were coming in to take his blood, even if they knew there was blood there, to use distilled water, because only people that work with blood or in a lab or has some kind of basic physics would know that the difference between saline, distilled, and tap water. So the next drip, I used tap water.
That's a huge difference.
It is a major difference because the tap water has different elements in it. You have, chlorine, you have all these different ingredients. So I thought to myself, the first one was controlled by distilled water, which would be what you see in more of a lab. And again, the ratio, you can make it work under the right environments with the right ratios in terms of equaling balance of liquid versus the blood drop. But I knew theoretically, if someone come running into his trailer, saw the blood and it became an opportunity grab, they weren't running around looking for distilled water. So I told myself, be real. What would you then use? Well, you would use water, because that's what you would just instinctively thought. If you're picking up blood and you needed it to get it into a something, you'd have to water it down to a degree. So here I wanted to use water to break up the clot because I believed that's what someone would use. And I do a few extra drops because I thought to myself, I have to be realistic. I have to put myself in their shoes. They're not going to know that you have to have a balance of percentage of water versus blood. They're going to just want to get the blood, water it down to make enough. And in their mind, I thought, again, this is very speculative, but this is why I did so many experiments, to more controlled ones and more speculative ones on terms of mind thought, and that's why I did so many, to cover every single one. And I thought they might have just panicked. They're not going to know. They just used tap water. They needed it to be liquefied. They needed to break it down, and they would just start doing it because they didn't understand it. So I used this. So I just wanted to, as you can see, it runs, and it actually, you can tell the difference between fresh water and the saline because of the distilled, because the distilled had more of a it kept it more intact, where this one, the fresh water, breaks it up immediately in terms of watering it down. It doesn't rehydrate it, it just kills it even more, and again, it's lost its color and texture. So there's no way, and in all, theoretically, we don't see this color in the RAV, do we? So I think it's fair to say that no matter whether it was EDTA blood or fresh blood, it is, in my opinion, after doing these experiments, that the blood we see was not rehydrated in any form. It was already liquid form.
Yeah.
Okay. Yeah. And the next bit that I want to show, so that this bit's interesting because I want you guys, this is, for me, is really interesting. And this is something me and Dr. Silkman have been trying to explain to a lot of people for a while. See that clot? There are no clots seen in the RAV. Therefore, it proves it was liquid form when dropped. It's not rehydrated or removed through the stages of 2 and 5. Otherwise, we would have seen that. That clot, we would have seen that clotting factor in the stains. But there's none. So again, it kind of goes back to what I was saying. It seems like it was already liquid form. When they drop, wherever it come from, wherever they took it from, it was already in form of liquid. The coagulated stage hadn't began. Otherwise, you would have seen this drop, a similar, especially with that, because it wouldn't have broken down. So you would have seen a pattern of the drip where it would have had little clots throughout it. And the next video I show you guys is I'm hoping this is going to be the most mind-blowing. I left it for the last one because it happens right in front of your eyes, fresh blood. But again, Dr. Silkman, now that I've paused on this bit, this is something that you and I have spoken about a lot. Do you want to weigh in on this moment?
Yeah, I mean, the trouble with the blood from the sink theory is that it will only work literally if you ran in, grabbed that blood, and you seeded the RAV immediately. Because as you've demonstrated, you're gonna start getting all different types and stages of clotting taking place. So it's going to be very, very hard to handle that blood. Also, the fresh blood without any EDTA is very, very difficult to rehydrate, right? So you've got all sorts of problems. But there's one thing I've got to talk about, and that is if you actually use distilled water or deionized water, you do something else to red blood cells, and that is you cause them to lyse. They will burst.
Yeah.
Because what happens is fresh water will enter into the red blood cell because the proteins in the red blood cell are at a higher concentration. So the water will enter into the red blood cell and pop it. You're going to get a mess, right? You're going to lyse your red blood cells. In order to prevent your red blood cells from bursting, you need to use a buffered saline solution at physiological pH, right? And there's no way, are you trying to tell me that the planter would have known that, right?
No way.
So you need to use a phosphate buffered saline that's at the same pH and same concentration as what's inside the red blood cell, so you get an equal flow of the solution. What you've demonstrated beautifully is that if you use water, even distilled water, the water will enter into the red blood cell and pop it. All the proteins and all the debris that's inside the red blood cell is now outside. right? You've destroyed the integrity of the red blood cell, which means you're going to get a mess. So see how you put that drop, how you've got little clotted. You can imagine that's a whole combination of cellular debris, proteins, outer membranes, clotting proteins. It's a huge mess. And you're correct. You don't see that in the RAV. That's a very important point. So I think you're safe to conclude that the blood in the RAV is not reconstituted fresh blood. I agree with your hypothesis. The blood in the RAV was in liquid form.
Yes.
So
now, yes, I just want to touch base on something though. When I say liquid form, I have to be very mindful how we say that, Dr. Silkman, because
correct.
I'm gonna say something that I don't want to discourage people, but it is a reality that we have to factor in, and this is called Occam's razor. It doesn't.
I know where you're going.
Yeah, thank you. It means that, in a sense of reality, it means that Stephen could have bled in the RAV, and I say that although I don't believe it. It is an option, because it means maybe not Stephen, but somebody. And I say somebody could have bled in that RAV, and it was real blood, because if Kathleen's correct in the samples she was given were Stephen's, and they are authentic to the RAV, and that is the RAV's blood, and that was found, then we do run into a problem, because then I'm like, okay, then how did they get Stephen's blood? What cycle was it when they found it at all? How did then they rehydrate it? We're now seeing the chances of that. Maybe it's possible, because maybe they got to it even quicker than 5 minutes. But again, that clot happens even inside the dropper. So if someone had picked up, and this is the next stage I was going to say to you guys, even if and you're going to see it in the next video, it's really going to show you guys the truth of this. Even if someone was basically standing next to Stephen Avery, let's say he was literally recut his finger open, he walked up to a surface, he dripped. The person had a dropper in their back pocket, they're standing right next to him. They said to him, you can leave now because I'm about to take your blood. So he walks away. They grab out the dropper, they pick it up, and then they take off. That blood in that dripper is still on a time. It's already on a time limit. The time has already started. The clock is gone. Well, not gone, but it's already going. It's ticking. By the time, you want to pray that that RAV is already on the salvage yard, because it has to be bloody close. Because if by the time you get to that RAV, that clot that you see here would have already formed in that dropper. So even when you drop it, you would have still had a clot drop out, because that's how quick the cycle is. And when you see the next video, you're going to see it with your own eyes with what I'm talking about. So again, I'll let this, unless you want to say anything else, Dr. Silkman, with what I just...
Yeah, I mean, when you think about the logic of it, you want the clotting process to occur very, very rapidly. Otherwise, I mean, there are genetic diseases and hemophiliacs, right? Where you lack clotting factors and you nick yourself shaving, you bleed to death. You can't form a clot, right? So therefore, for biological preservation, that you want the clotting process to occur immediately, right? As soon as the blood is exposed to the air, it means that it's no longer inside a blood vessel, right?
Exactly.
So therefore, you want the clotting process not to take 5 or 10 minutes, but to start occurring rapidly. Because think about it, if you cut yourself, you want to prevent total blood loss. You want to save your life. So the clotting process has to occur immediately, right? So even though, you see, what you're seeing here is a gross clot. But if you were to put that under a microscope in real time, the clotting process will start to occur rapidly, right? So it makes sense.
Your own eyes. So
correct.
I just let this video play out. a few more minutes. Again, you can see it's still gelling. It's just at gel stage. So that concluded the bath. Well, there's a lot to it. I just broke that down because I wanted to show you guys the comparison to what you saw at the very beginning with EDTA. And at that stage, as you guys remember, if I can just go back to show you at best how, let's have a look. The very beginning, look at that. So that was able to turn into a liquid that you could drop again, and although it was watered down, it still maintained a similar texture and color versus the fresh blood.
But if you remember what I just said a couple of minutes ago, Kelly, if you add distilled water, you're going to get some form of lysis, right?
Yes.
The red blood cells will pop, which means that you may get a slight, because remember, you've got heme in the hemoglobin, etc. That's the red colors, the iron, right? Plus now you're exposing it to oxygen, so you get biochemical changes taking place. If you were to add buffered saline solution, that means you can totally reconstitute those red blood cells, almost like fresh blood again, right? Because you don't pop the cells. They remain, the integrity of the membrane is intact.
Yep. Okay, so this bit I wanted to get more authentic. So to the car I went. Now, this was another experiment I did because there was a few days that I had to take blood. So this was yet another one. This was fresh, straight out my arm. Basically did it in the garage while I was standing there. And my objective to this one was to create a new surface, show you guys a car surface. So we're taking it away from porcelain. We're taking it out of the control of, the air conditioning, and I wanted to just drop it and show you guys fresh blood in a car. I thought it would make sense to everyone because we know that the Grand Am had blood drops. We know that Teresa's ignition and her RAV had blood spots in it. So I thought, let's keep it real. So here, I dropped some blood. Now I want you guys watch this with your own eyes. See that?
Wow.
See that clot in front of your eyes?
Yeah.
Plotted right in front of you. Now it gets better. Watch this. This takes about a minute or two, but it's just watching it with your own eyes with what is about to happen. So you can see right there, the coagulating has started. You can see it right there. It came out of the drip like that. It was already forming. Let's keep an eye on it. And this is why I said to you guys I have to do a lot of editing, because I set up cameras and sat and watched it and left it for hours on end, and this is what you just look at. So that's what I have to go through. I have to go through all these videos and cut it down where it's realistic. Otherwise, you're going to be watching up to 10 to 12 hours of just blood drying. So how many minutes are we in? We're 1 minute and 4 seconds in, and as you can see, I'm pointing out that it started to here's like the blood residue where it dropped,
layering,
where I first
right?
dropped, but it was drawing in because gravity was pulling it down. So it was already starting to dry here. The clot is more defined right there. It's already dry in some places, and that's 1 minute and 16 seconds. Look, there's nothing, it's still there, it's dry. I just focus more on I want you guys just to watch it with your own eyes. This way, you don't feel like Amber Heard being gaslighted, just seeing it with your own eyes. The most magical bit is about to happen, and I hope you're all sitting down, y'all, because there's something that
pay attention to this part coming up is really good, guys.
So this bit, it's already began. The coagulating in the syringe, it's blocked with a clot. I couldn't get it out. I had to squeeze it over there, squirt it out.
Your blood
And when
sample, the stuff you took out of your arm,
Yeah.
you couldn't even get out of the syringe?
Look, there you go. Look, it's already had clotted at the end. Look, it had blocked.
Wow.
So, and you guys
really don't have a lot of time to do this at all.
You don't have a lot of time. We're now 2 minutes and 5 seconds in that you guys
in
are
2 minutes, you're done. So you got to pull the blood and drop. Yeah, okay. All right.
Okay, so if you guys can see here, when you saw me, because you see, I'll go back a little bit. I'm trying to squeeze it out. It's not coming. And then I take it off and I didn't realize that I didn't adjust the camera properly. So that is my apology, but I was using the camera and I wasn't focusing. When you see the second drop, that's what I had just used to, I didn't realize that I squirted it on the side there. And as you can see, when the clot dropped, see that little drop there, like it squirted out with it. So that was me releasing the clot from the end. And then I come back when I know that the clot's been broken, and then I'm able to drop it again with a bit of pressure, and I have to shake it, and then I show you that it's still there. The clot, that not all the clot had been squeezed away. So clot formed. Now watch this. Back to this. Still drying. Okay, here we go. Watch very carefully the top. Watch the top, guys. It's starting to peel by itself. It's peeling. Pop! It just flaked by itself. Boom.
Wow.
Fresh blood just flaked by itself. Now watch
this. Instant replay on that? Let's get an instant replay.
Watch this. We have flakes, everybody. Natural flakes. And took 2 minutes and 37 seconds. Bang. Let's go back. Look at that. Huh, I saw it. You see it the moment it flaked off. Let's go back. Let's watch it peeling. Get ready. Get ready. Watch carefully. It's starting to peel. It's peeling, peeling. Pop.
And that's because what's happened there is that you're getting a constriction of all the red blood cells because everything is being drawn tight because it forms like a mesh network, right? So instead of being free flowing, everything is congealing together and it's forming like a mesh. And because the gear lever shift is non-absorbent, it pops off, and that's dramatic.
Its analogy is like a rope net, a net of ropes, right? A rope
yes, it
net.
is.
And if it's wet,
it is cross-linking.
It kind of sags, but when it dries like tight and crusty.
Yes, it does. It forms cross-linking. So you've got now a mesh network of red blood cells, white blood cells, platelets, all these proteins which are cross-linked together, right? So what you've demonstrated there, Kellie, is the clotting cascade of fresh blood that now explains why you've got blood flakes on the bottom of the RAV4.
Glad you said that. So let me just keep going there and I'll explain to you guys something. So there you go. I'm just showing you guys it's dried, it's flaked off. Now I'm showing you guys, look at that. You can see the pattern of where the blood, there was the blood, and there's just like a slight residue behind from where it was stained. But the whole thing has popped away. It's clean. You wouldn't even know. We don't
see anything like that in the RAV, do we? We don't see anything like that in the RAV where it's like missing like that, where it would pop off and leave a trace mark, do we?
There's not.
Here's the catch. This is where I was going to go with that. So,
okay, I'll just be quiet and let you do your thing.
So here you can see, obviously, the bit that I squirted out to get rid of that clot. That was already dry. So I don't know how long. I would have to go back and count how long it was between those two. But look at that. Look at that stain. It's dried out. Look at that. And it's left a little crusty flake itself already. Look at that. You guys saw me drop it. And that one, because it was a bigger squirt, it's coagulated. That was at this probably, I think it was probably stage 2 or 3. It was, if I would have touched it, it would have had that gel light where I would have, when I moved it, the clot would have moved with the dripper. So my point of that was, I thought to myself, what does that mean? What does that mean that it was able to flake off in front of in front of my eyes, in front of everyone's eyes now? What does that mean in terms of the flakes in the RAV? And then I thought, holy shit, could it mean that when someone was planting the blood, they had dripped a stain that they didn't realize had dripped on a surface, and over time, it just naturally fell off by itself? That's why we're seeing it. No one had to plant flakes. This is a natural thing that could have occurred from a stain we just didn't see and they had missed. And the reason why I want to say that is because I want everyone to thank Justa Denny for this one. But we have proof that there is stains now in the RAV that they ignored. So when Justa Denny it was probably last year when I was doing these blood experiments, and I was sharing these blood experiments with a few people, Carla, Kaf, Justa Denny, I can't remember, there was a few other people, I think it was Ziggy. There was a few people that I was sharing it with, and Jess, Justin's wife. We would all be online, and I would do basically what I'm doing now, open up my screen and show everyone. And Justa Denny started going back and looking at the RAV to compare what I was finding to what pictures we have. And he came back and goes, holy shit, did anyone ever talk about this stain? I said, what stain? And on the passenger inside door panel, the exact area that we see on the passenger rear, it's like someone had started to do another drip because there's a blood stain that no one even documented. So there is stains in the car that they didn't process. So there could have been a stain on the ignition, on the side of the panel, on terms of like the gear shaft. I don't know what you guys call it over in America, but the gear shaft, the center console, that it could have naturally flaked off. Gravity. And then Kath said to me last night something really important. You got to remember, we don't know when the blood came into the RAV. So for all we know, when they were moving it around and it was traveling, it could have flaked off naturally from a surface as well that we didn't know. So when they went and looked at the RAV and they processed it, they were just finding the RAV flakes on the floor because they had missed the source of it, because like we see in that video, it doesn't really leave too much of a mark, just a little residue that if it was small enough, they would have missed. There was only like a few flakes. It wasn't like an excessive amount of flakes. You guys saw that top bit. Look how many flakes I was able to get out of just that little bit that popped out once it had broken apart. So again, I just consider that, you know, Kathleen saying that the flakes were planted in the RAV by someone who might have scraped the sink and took blood and done this and done that. The state's narrative is saying, excuse me, it's from his finger, I guess, when he cut it and he opened it up and it was flaked from his finger or whatever bullshit they said. I think that's so bullshit, I don't think I've even really let that one sink in. And here I am saying, you know what, both of them could be not even fucking plausible. It doesn't have to be planted. You just saw it with your own eyes. It could have been a natural flake from a surface that just dropped off somewhere that we just didn't know about. You guys saw it with your own eyes. It's plausible and possible now. I'll go back just to show you guys one more time. So you guys can see how quickly this moves, because I think this one again is one of my favorites, because you watch it happen in front of your eyes and how quickly it moves. Just that, it blows me away, that clot that you see just formulate just straight in front of your eyes, bang. And then let's obviously get to the part that matters. Having troubles, the clot. And here we go. Pop. So that's basically what I just wanted to show you guys today. I wanted to show you guys some fresh blood experiments that I had done. I wanted to parallel them into the case. Again, this is the disclaimer that I've been very vocal about. These don't give you conclusions. I don't know whether it's up to you guys as viewers and the panel members to make their own, interpret it how you guys see it. It's up to you guys. I'm not here to control anyone's narrative. I'm not here to change anyone's opinion. I just wanted to provide some information so you guys can understand the basics of blood. And I think I'm quite proud of what I did, because I think as small and constructive as they were effective, that you get to see them. And yeah, I just wanted to share that with you guys. So thoughts, I guess.
Well, I think you make a great point at the end there, Kel, when you say that, you know, these are just little pieces, and that's all we can do. No one's ever going to be able to take a comprehensive look at the whole case. It's too big. This is how we're going to get a clearer understanding of what's going on by, you know, breaking these things down into the minutia of details and going through these experiments so everybody can kind of understand when they're talking about EDTA and they're talking about fresh blood. What does it look like? How does it move? What are the differences? And what you've done is eye-opening for me. And, you know, I don't want to speak for everybody in the comment section, but it has been nothing but appreciation so far. So that's where I'm at. We'll open it up. Dr. Silkman, if you have anything, otherwise we'll open it up to take a few questions from the chat. See if we couldn't get some other voices.
I think,
thank you,
yeah, I mean, they were really elegant experiments, and thank you so much, Kelly. I think that now explains the origin of the flakes within the RAV4, that they must have come from an area of blood that had dried and popped off and fell to the ground by gravity, right? There's no evidence of any blood or type of staining on the gear shift lever. The only place where you see blood is near the ignition switch, which begs the question, was there an area near the ignition switch that had dried, flaked up, and fell to the ground by gravity, right? That makes sense. But now the $64 million question for me is this: does EDTA blood dry and form a flake like that?
I'm glad you asked. Let's have a look. I do,
because
that's gonna open up a big kettle of worms.
Dr. Silkman, I thought it was the $64,000 question. Is that because of inflation that now it's $64 million question?
It's because it's my birthday and your birthday.
Happy birthday again, Dr. Silkman.
And to you too, Jeff.
Let me just see. Oh, these are just one of the folders. I cut myself on the foot and I sat there for 5 minutes, and I was so excited because we got to watch it dry and coagulate. I've never been so excited to be hurt in my life.
You can easily edit that up to say, I cut my foot and I was so excited.
Just trying to find.
So what are you, it doesn't seem like we have any direct questions. Maybe there was something up in the chat earlier. I'll take a quick look and see.
EDTA blood flakes.
Right. Okay. So the EDTA itself, EDTA blood, once it desiccates, it can form a flake structure. Is that correct?
That's correct.
Okay. But if you have a look at how did you form those flakes? Did you scrape or it occurred naturally?
No, okay, so there you go. That was the source it came from. So when I was doing when I had, because remember I told you guys, when I did my experiments, I had to have my method, the container I was using, on a certain angle. I had to get it to a degrees that matched a car panel of like that angle as best as I could. So when I went into the bath and I used the bath and I had it on the angle, that was from where it leaned up against the bath to keep it like up to the angle that I had picked. Well, not picked, but it was mathematically design from my car side. So when I removed the container after a week of having it just sit there, that's what it was coming from. The flakes was coming from that source because it had been leaning. I don't know if I've got, because there's see if there's a picture here of how it was. I've got to update it because I've got 2 computers and I'm not connected to one of the computers, and the other one's got the other 3 files of all my blood. I've only just started bringing it onto this one. Let me have a look if it's here.
So the question I'm asking, and this is a very important one, can you rule out EDTA blood with EDTA in the
No,
breath?
you can't. No, you cannot.
The
EDTA blood could have also formed the flakes and created the same thing. You guys saw it with your own eyes on the middle video where I was able to create flakes the moment I added a bit of movement to that stain on the bathroom, on the bath. It broke up into a flake form, like a crystal flake form. But this one, this is just a picture of one of them, but just to give you guys an example. Oh no, it's a video. Okay, hang on, what's this one? So, okay, for example, so you see this bit here, Dr. Silkman? I don't know if you guys can see it down here. This is where
I'll be watching.
Because I'm standing over on top here. I'm looking down on it right now, but it was on an angle, and this is leaning against the bathtub. So when I was doing my experiments, sometimes it would run all the way down and then the liquid got trapped between there and sealed. So when I took this away, this was one of my very first videos, which I ended up discarding because I realized I could do it more efficiently and capture it better. I was such a rookie. I was writing the numbers when I realized I could do it differently and capture it differently in terms of detail. So when I would, the blood would go there, and when I removed this container, the blood flakes started to drop, and that's when it dropped into the bathtub. So yes, and this one was fresh blood, but the one that you see the flakes from is EDTA. So to answer Dr. Silkman's question again, yes, EDTA would also form flakes. So it could be EDTA. Well, I'm not going to say, it could be that.
Could be.
I'm not saying it is, but it is an option.
Possible. Well, yeah, we got another set of eyes here on the stream. So welcome, Denny, in with your opinion. Denny, what do you have to say to what you just saw? Or do you have any questions about what you saw for Kellie?
No, I don't really have too many questions for Kellie. The only thing I wanted to correct her on was that picture that she showed of the car door. That was actually the driver's side front door, where I happened to find that.
Oh, okay.
Looks of blood to me, but
absolutely. So, yeah, I mean, we just saw a lot there. What are your impressions of it, Denny? The way the blood operates? Do you have a clearer understanding of this, or you feel like you got it?
I feel like I understand it pretty good. Like Kel said, we've talked about this in the past and gone through some stuff, so I've seen some of it with her. I mean, just actually watching the experiments as she goes through them, it's something that I've never thought of doing myself, so it's pretty interesting actually going that route.
Right on. Okay. So
I was just answering a question from Everly. Yes, air temperature has definitely got an effect on how quickly blood will clot. The warmer it is, the quicker it dries. That's why when I did my experiments, that was one of the major factors, was temperature control. That's why I went back and I looked at all Wisconsin's weather. Again, I'm in Australia. I didn't get it perfect. Never even seen snow. So when you guys are cold, you guys can be snow cold. We don't get that. The best I could do was I was manually cooling stuff down on top of controlling it with the environment that I could. So I was obviously using my air conditioning, which I showed Jeff Jones, my panel and the zones, to kind of give him an understanding of what that looks like in my home. And then I would go in there manually, because that was something that me and Justa Denny would actually spoke about, because Justa Denny said to me a few times, is there any way you could put it in the freezer? Because you want to make sure the surfaces are cold. Do you remember that, Justa Denny? And I'm like, I can't get this into the freezer, because we're concerned about, the RAV theoretically was sitting outside and it was exposed to elements. Whether it was locked, the doors were closed, it was still exposed to air in the RAV under whatever the elements of the temperature outside. And we know that it was rainy, it was gloomy, it was not warm. There is talk that there is a phone call on the 31st when it sounds like, this is not confirmed, this is speculative, but if it is cool, we had to consider, if it was cool outside that time, did Stephen have like a heater on? Did he have something warming his trailer up, being such a smaller trailer? Would that have affected everything? If he had warmth in that in his home, what could have been affected? Would that have changed? So I had to take all that. So I was sitting down some days with manually putting ice packs on everything, over and over, and rotating them and then getting a thermometer and checking it. And I was getting it minus, I think the lowest I got it was probably, I think the room itself, I got it down to 7 degrees. I don't know what that is in Fahrenheit for you guys, but it was 7 degrees for us, Celsius, which is really freaking cold. And I was able to get the surfaces down to minus, I think it was -1, because I was literally applying ice to it to cool it down. And then I would do an experiment with it being completely cooled down. And then I was doing alternative experiments where the surfaces were just naturally conducted on the air environment. So we were getting the balance of both worlds to see if it would affect shit. And literally when I showed you guys the blood flakes from the EDTA there, if you've seen that little drop, that stain, if you go back, I've stopped sharing my screen because I wanted to focus more in on here so I can concentrate. You'll see that like stain where it looks like water has hit it. That's because of the condensation, because the bathroom actually got so freaking cold, and it was a bit moist. It got a bit moisture in it. I hate that word, moist. Correction. The moisture had dripped, a blood drip, or it might have been from when I was adding saline or where I was adding something. But I did notice there was a little bit of moisture in the room when I walked in on some days as well. So that was a natural drip. It wasn't created intentionally. So I just want to confirm that.
Absolutely.
And yeah.
Welcoming a new face to the live. Calf is here. This live is now caffeinated.
Hi, everyone.
Calf, do you have any comments about this? Like that you've just seen a lot.
I've seen a lot before, so
yes.
It's just going over what Kel's done before. It's very interesting. I can definitely see the patterns from what Kellie's making to the patterns in the RAV. Like it's identical.
I haven't shown them all that yet. Kath, I haven't shown them that stuff yet. Like the patterns. That's like the mic drop moments I haven't released yet.
Oh no, but just what you're showing already.
Yeah, show
like
that's
you
fair.
can definitely see also too with the flakes on the carpet. I think Kathleen Zellner and her experts did some you know, try and reenacted how flakes could have formed and whatnot, and the blood didn't soak into the carpet.
No.
So
No.
it was just sitting on the top. So it could have easily flaked off from anywhere else in the vehicle and landed there.
Yeah. Yeah. The thing is, no one in a planting scenario, no one in their right mind is going to plant flakes, right?
No.
And so what Kellie demonstrated really elegantly is that if you have an area of blood contacting a surface that is non-absorbent, an area that specifically dries can potentially form a flake and fall off, and by gravity. And because it's already a flake, it means that it's not going to absorb into the carpet, right? So very, very important. So in other words, you have to account for all the things that you see in the RAV. Now, don't forget, there are some stains on the seats themselves, which meant that the blood was in liquefied form, fell onto the seat covers, and then got absorbed into the fabric. But then
I don't think much blood. I don't think much blood. You know what I mean? Like not enough to soak into carpet, maybe a little bit into the fabric, but not. And you know, you're seeing how much Kellie's using. It's the most tiniest amount, and it goes such a long way.
Correct. But what we need to work out, just one other point, because the clotting itself is a biological process, it works optimally at body temperature, right? So body temperature, that's when you're going to get clotting taking, because these are enzymes. They work optimally at 37 degrees, your body temperature. If you drop the temperature, you're going to slow down the clotting process, because remember, these proteins work optimally at 37 degrees. You drop the temperature, and potentially you can affect the clotting process. But here's the problem. We don't know where that RAV4 was when that blood got deposited in the RAV. We don't know. We do not know the conditions. Was it a warm garage? Was it out into the open where it was really, really cold? The problem that we face, guys, is that time has progressed. Do you understand? By the time they got to look at the RAV, many days have gone by. If you say that Teresa Horbach was killed on the 31st, the 6th is the first day that they look at that blood, take pictures, do a swab. So a lot of time has passed. And Kellie has shown within a few hours, with the blood that's got a natural blood, whole blood from your body, within a few hours it's gone, it's clotted, right? Whereas the blood that's in the EDTA form, right, you're not going to form the same type of structures because you've got EDTA. It's going to remain in the liquid form, but give it time, it desiccates, it dries out. So it's very interesting. My interest in all of this, can you tell the difference between blood that's fresh as opposed to blood that's got EDTA? That's the big question for me.
In my opinion, yeah, you can.
Whoa. Guys, I'll be back. Keep going, keep going. I'll be back.
I would have to agree with you, Kel. I think you can pick up a difference in it.
You can pick up a difference in it. Natural blood, this is the problem I have. So the what we see, okay, let's compare it. Let's be real, guys. Let's look at Teresa's blood in the back. Now, why I've always thought that is more authentic is because it's the color. The color we're seeing is what it should be. It's gone rusty. It's gone brown. It's coagulated. There's some forms of it that you can see. There's like almost like a little bit of a crustation where the hair might have been, like it's protruded out kind of thing. It's bubbled. Where you look at the RAV and it looks so much more fresh, like it's still just liquid form. That is a difference. So the problem that I have with that, though, is there is all these factors, and these are the factors that I was talking to you guys about. This is why I always say there is no conclusion, because the factors then is temperature, lighting, the camera they're using, whether the pictures we're seeing were edited, and we know that they are. We know that some of those pictures that the state had was edited because the original pictures versus what they used in the trial, they had turned up the contrast. They turned it up so much, the blood in the back looked dark red, like it looked vibrant. So we know that we have to be very careful and mindful that lighting, again, all these factors are a problem.
I was going to say, Kelly, we've got an actual internal control in that RAV4, and that is the blood back. The blood in the back,
correct,
is from Teresa Horbach. No EDTA. That's fresh blood. We've also got another internal control, the blood in the Pontiac Grand Dam. That's fresh blood. There's no EDTA. So the question is, does your experiments differentiate between what we know as fresh, non-EDTA blood as compared to the blood at the front of the RAV that the state is saying belongs to Stephen Avery? Because can we actually tell, is that fresh blood? Did Stephen really bleed in that RAV, or was it blood from another source, right? The only person who said that Stephen Avery's blood is Cherie Culhane. That potentially could be from anybody. We don't know. We have to take her word for it, because the other source of blood is on the back door of the RAV4, A23. Presumably, that's fresh blood. That doesn't belong to Stephen Avery. So you've got all these dynamics that are in play. So it'll be, and I agree with you, you change the lighting conditions and that blood can look completely different to what we see in those photographs.
I think the blood in the back of the RAV is a completely different colour for a start. It looks like older blood, which sort of turns a brownish tinge over a period of time. I think it's somewhere like, how many days is it, Kel? Like maybe 3 to 5 or something?
Yeah. Oh, you mean the blood in the back?
Yeah, in the very back.
The blood in the back for me, I think it could have potentially been there as of earlier, as soon as the 31st. That looks like it's been there for a lot longer than the blood in the
yeah, that's what I was getting at, but I wasn't sure of the time frame of where it changes color.
You see, that's the internal control, because according to the state, Teresa Horbach bled at the same time that Stephen deposited his blood in the RAV4.
And that's the problem I have.
Period. That's it.
That's a big problem.
That's a big problem for the state, because that does not match what we see. Otherwise, we would see a contrast of all the blood looking at the exact same cycle in terms of clotting, everything. The blood in the back would be matching the blood in the RAV itself in terms of the ignition stain, the blood drip. It would all be at the same stages because it will happen on the same time. It was exposed to the same elements. It was exposed to the same temperature. Everything had the same. The only thing that people don't know is there is something other than Teresa that Stephen may have had different. And in my research, again, I was going to save this to being a part of the main presentation I did, but I'll disclose it now. Stephen was on medication, and certain medication can have an impact on blood, especially if you're on a blood thinner. So blood thinners work essentially like EDTA EDTA chemical, because it stops the blood from coagulating. It stops you from internally forming clots that would get trapped in your arteries and give you PEs and strokes and heart attacks and all these things. So when I went back and found it, he was on medication. I think it's called Antenol, 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 I think, Antenol. And that when I took that to the consultants and we sat down, I said, okay, let's break down the chemistry of this drug. What does it do? Would that affect his blood? And they said, okay, so that medication is usually used to control blood pressure. Someone's got like a bit of a high blood pressure, and sometimes it stops you from having chest pains, and it just opens up the vessels. It doesn't, in their opinion, affect the blood itself. It's not a blood thinner. So it doesn't fall into the category of a blood thinner. So I said, in your all honest professional opinions, does that affect my samples? Does that affect my experiments? Do I have to put myself on a blood thinner for a few days? Firstly, they told me, don't be fucking stupid. They said, don't be that dedicated to yourself in this experiment. And secondly, no, you're actually safe. You don't have to do anything different. I was like, okay, I better not tell them that I had already started taking aspirin 2 days prior, just to be sure. Because aspirin is one of your regular blood thinners. If you're ever, here's a little disclosure for anyone, if you're ever at home and you feel like you're about to have a heart attack and there's no one around, if you have aspirin in the house, take some immediately. You'll then buy some time, hopefully, to maybe be able to call emergency and get services to you, because the aspirin will hopefully slow down that clot if that's what's about to happen. So that was a little bit of medical advice without legally giving you medical advice, because I'm not allowed to legally do that. So just pretend that was just a draft. Sorry.
No, I was just going to say about the colour of Stephen's supposedly blood in the car. Why is it so bright?
So here's the problem with that. We don't quite know.
Well, even with the flash going off on it, I get that it might brighten it up a bit. Still not as bright as Teresa's blood, but
that's
it almost looks like that we have red paint at some points.
Funny you should say that. So although I didn't try red paint in my experiments, I did try something that has been going around as a rumor or a possibility for a while. Because it was Halloween, you guys could imagine what people have considered.
Except
fake blood.
Except they did presumptive tests.
Exactly.
For globin, right?
Exactly.
They will rule it right out, because if it was fake blood, it's not going to be presumptive positive for blood.
It actually doesn't work anyway. I just want to let you guys know. I did, because like I said to you guys, you would have heard yesterday in the premiere, I tried basically everything that was out in the community. I tried to recreate, well, not recreate, recreate's the right word. I was trying to recreate thoughts out there. And one of them I found was people were saying, oh, for all we know, it could have been fake blood because it was Halloween and someone's just that they've squirted fake blood. So of course I thought, well, hell, I've got fake blood here. I might as well give it a go. I can tell you one for the simple explanation that Silkman just gave us, or which was it wouldn't have come back as a positive presumptive test for starters. And secondly, fake blood doesn't dry. It's liquid. It's very liquefied. It doesn't dry like blood. It just runs. It doesn't rust out. It doesn't. And it dries weird. It doesn't crust because it doesn't have coagulations in it. It doesn't have all the proteins and stuff. So it doesn't do anything like real blood, EDTA or fresh. So I can say to you guys right now, with confidence,
it's not fake blood.
It's not fake blood. I even tried tomato sauce. I did everything that was out in the community that I saw online, and I did it, and I laughed because I drove around for a few months with blood, fake blood, tomato sauce or ketchup on my ignition for months. And my husband who used to have to use my car, sometimes would go to me, for the love of God, get rid of this shit. I am so sick of it stinking of, like, I get a whiff of ketchup one day. There's a weird smell with the next day. For God's sake, for the love of God, get rid of it. He goes, and if you ever get picked up by the police, it's not going to look good that it looks like a crime scene's happening as we speak. And I was just like, shut up, my car. So, what you guys see on the screen is something that I want to bring up as well. And that kind of goes into what we were talking about in terms of, the blood and whether or not, when I said to you guys earlier that we have to consider that, it was liquid form, and I don't want to say it's Stevens, that he actually physically bled in the car. But the problem that I have, I always believe there was a time that I considered an option, and that option was, what if it's the real killer's blood? What if somebody is all of the blood in the RAV is, besides Teresa's, of course, it's all A23. And all they've done is they've just taken Grand Am swabs, and all they have then done is pass them off and swap them out to say, well, this is Stephen, and this was where we got it. We got it from the RAV. And if it ever comes out that they fucked up, they would just go, oh my God, I'm so sorry. We had it all drying on the same shelf, and we just accidentally labeled the wrong ones.
Correct.
Okay.
Correct.
So I always considered that as a possible plausible explanation. However, Carla sent me something really, really interesting. And when I was going through this stage of feeling like I had cracked the code in my own head, no, it's the real killer's blood. She reminded me something. She sent me something from Kathleen, and this is what she had sent to Honourable Flowers. And here she talks about the when she was doing testing, because she was trying to get the, what is it, the when you age the blood, Dr. Silkman, what's it called?
It's DNA methylation.
Methylation, yes,
DNA
blood. So this is, yes, so this is what she was sent and what she had. So she was given, and I quote, item A6, which is a blood stain cutting from the RAV4, the driver's seat. Item A8, which is the swab from the ignition. She was given item A. No, hang on. She wouldn't have been given that because that was used up. You know, but, oh, this is what she asked for. And then she goes on about, it's a bit of a breakdown. I'm happy to share the link. It's a breakdown of everything that she kind of was asking to test and what she was asking for. And then she kind of goes into about how on the dates they were given certain things. And she said she was given items A6, 8, 8, 8, 9, 8, 10, 8, 12, such and such. And that they sent it to Dr. Well, who was it? Where we're looking. Oh God, where am I looking?
I don't think Dr. Wright did the DNA methylation.
This is basically saying they weren't able to do it because it wasn't enough, that they didn't have enough to conduct the methylation. But where I'm going with this is the thing that kind of put me in my place was she sent A6, and A6 was blood stain. It was fabric. It was the RAV's fabric, and it had allegedly Stephen's blood on it. So she's got that, and she confirmed, because she ended up using A6 and the blood flakes later to confirm her latest methylated test. That's how she was determined that it was from a 43-year-old male, and it was Stephen Avery. So I'm like, well, shit. It's one thing to give swabs and hide that, but I find it probably a little bit more difficult to fake the fabric because it's from the RAV. It's authentic. It's the RAV's seat cover. It's a little bit difficult to create that and give it to her. Unless, of course, there was more fuckery going on and they went back and grabbed blood and his blood and did it more spots, cut that bit out and then gave it to her. So I then had to consider the reality is the source is obviously Stevens. She's confident in this documentation that it's Stevens. And that, and this kind of comes back to when she says in, I think it was Ma'am 2, and she's sitting there, they said to her at that stage, and what are you going to do if it comes back that it's fresh blood? And she goes, well, then shit, I don't know what we're going to do, that we're going to have a bit of a problem. Because at that time of that interview, this had happened yet. And now we know it has happened. And then she changed from EDTA vial being maybe a possible situation to, oh shit, I now have to fucking drop that. I have no choice, really. I have to go on to a source that has his fresh blood because we've got fabric now. Take it, again, this is all about interpretation. You guys might read this and go, hang on a minute, maybe there was a way they got around this, and that's fair. But I just think that that's more in your face proof that we are looking at Stephen's blood. It's not another person that they're hiding someone's identity. Anyone else?
I was just thinking with the, because like they'd have to use Stephen's blood, because if they didn't and someone wanted to come forward and retest anything, if Sherry had left anything to be tested, then, and it wasn't Stephen's, then that, it's all over right there.
Yeah.
So yeah, as much as I think there was probably some dodginess going on, they're
So
not,
what
I
is
don't
this
think they're
document?
risk not using Stephen's.
So this document is, let me copy it.
I agree, Kath, what you were saying. Absolutely.
And they didn't have very much of it, but where did it come from?
And then it goes on about the key and how he did the key, and then the other thing that he that came up was when I was reading it, I was skimming it, and I was like, oh shit! They confirmed that the under hood swab was not from saliva, not from blood, but it was from his skin cells. So that has now been confirmed that it was a skin cell. But we all knew that. But again, it's obviously not sweat, but it's a skin cells from contact.
Like a
so
cheek swab?
No, because it's not. It's not from saliva. It had no salivering compounds to it. It was just skin, like a transfer from holding it or possible contamination. But when you read this report, it basically outlines that the levels were way too high. It made no sense. The levels that they had in their lab was so minimal compared to what Sherry Culhane was pulling out. She was getting like 10 times the amount of what they were pulling, and they were doing experiments with it. And I think we see that on MAM too, when they get him to hold the key for 15 minutes, they take it back. Well, this is basically her report on when they had done that. So they outline that as well in here. I'm just trying to find, again, I had it up last night. I should have been more prepared. I didn't know if we were even going to get to this. That's why I didn't really prepare as much as I did for it. I just had it on the side. It just goes on about how they examined items A6, A8, A9, A10, and A12 and determined whether DNA was present, was sufficient quantity for the DNA methylation. And then after analyzing these samples, they determined there was probably an insufficient amount of DNA present on the swabs. So they had to basically disregard them until further notice. And then it says a bit later on, they ended up sending more to her. And that's when they go back to the flakes, which is, this is the part where they said it did not come from his blood, saliva, and skin. That was about item I, D, and C, the hood latch swab and Toyota key. Oh God, it's frozen.
Andy B's got a question.
What's the question?
The blood was from a 43-year-old male. Did I hear that right? And then the carbon dating of the blood seat cloth sample, I mean.
All of it. The entire RAV came to all this report basically sums it up. I'm just trying to get to that bit right now. Hang on a sec. You guys keep talking when I try to find it. Hang on.
I watched Exhibit A last night on Netflix. Have you guys seen that?
I have not seen Exhibit A.
You need to watch it, like, seriously. It's about cadaver dogs and DNA. And
yeah, I'm really curious about that one.
Yeah, it doesn't go for that long, but they jam in so much information. Seriously, it's so good, like, especially pertaining to this case. It really made me sort of go, quite a lot through the show. Especially when they had an expert on DNA and how they can extract DNA from, say, a shoe, for example, multiple people's DNA. It made me stop and think about the key, how it only had Stevens on. You know, this guy's talking about extracting four people or so from one thing.
It just seems that every detail is like that in this case. You know, it's like every detail, it's like is suspect somehow. Even the key, yeah, you found his DNA, but you only found his DNA. It's a great point.
Exactly. This expert
like,
on this show,
everything is like that. Every detail.
Extracting up to 4 people.
Okay, so here, so it says they examined item A7.
I don't know if it's possible to zoom in just a little bit there.
The blood flakes recovered from between the center console and the driver's seat of the victim's vehicle to determine whether DNA was present and was of sufficient quantity of radiocarbon testing. They determined that the quantity of the DNA was too low for radiocarbon testing. And then it goes on about Dr. Mason to combine. So then Dr. Mason was to combine with the previous sent swabs to attempt DNA methylation testing again, because only 1 nanogram of DNA is needed for reliable DNA methylation test results. Mr. Avery's counsel is expecting Dr. Mason to report on his efforts to conduct DNA methylation testing with the additional flakes added to the prior insignificant DNA samples from the swabs. So we have, if you read up, it goes about the swabs, the fabric, and the the swabs, the flakes, and the fabric are the 3 things that they use to form a methylation testing. So they all matched the one individual, and it came back DNA Stephen Avery, 43-year-old. So this is where the guilters pull up Kathleen, though, because when she wrote this in 2017, she said that they couldn't conduct it. And then last year, she's now saying it was done. They're saying that she lied because and that's why, because she's never released these reports yet. She still hasn't released them, hasn't attached them to any motion, nothing. And they're like, she's going to be in a bit of a world of trouble if she did get the results in 2017. I don't believe that. I think that as technology has advanced, I think probably maybe in 2020 or 2021, she's gone back and done retesting as it's advanced, and she's run through and was able to then conduct these tests, because back then it says she couldn't, but they were holding on to these specific items to do later. When the test became more available, because like it says here, you only need 1 nanogram of DNA. And she's now saying they finally got it through these sources. So again, open for interpretation. But I just thought we have to bring it up that there is a more than highly likely chance that it is Stephen's blood, and it's not about the swabs. Take away the swabs, we've still got the fabric. She's got the fabrics and the flakes, and she's confident it was Stephen, and it was Stephen's blood at the age of 43. Now, if that's the case, then everything that I show you means the vial means nothing, because we know in 1995 was Stephen 43 years old. How old was he then?
Making us do math? No.
Yeah, I don't do maths. I couldn't even count to 12 the other day when I said 7, 2, and 2, and it was actually 7, 3, and 2. So please don't listen to a fucking word I say when it comes to maths. So let's do the maths. He was born in 1962. Okay, so I'm stuck up. It was 1962, 1996. Let's take that away. So he would have been 31. So 31 would have been what was in the blood sample in that vial. She put him at 43 years old at the time of 2005. So in 2005, he would have been around 43. Yeah, 42, 43, and that's what she's saying. She's saying that her methylation test has come back as him as being 43, not 31, which what the vial would have been. But then here's the problem that me and so Dr. Silkman say is we don't know what happens to that blood in a vial. The blood might stop coagulating it, but doesn't mean it doesn't age it. It just stops it from coagulating. So for all we know, it could be aging while it's sitting there. So by the time she's dropping, let's say the vial was ever used, when she's testing the blood, does it still rule out the vial? Because again, there's not enough studies to know what the blood's doing in the vial. But then here's the other problem. I believe she got the vial and she did some testing on the vial itself. I haven't looked too deep into that side of it. I know that she's mentioned it. So these are just all these factors that we have to consider. You can't, and that's what I said to you guys at the beginning. I don't hold anything back because it's not favorable. I don't need it to be one way or the other. I'm just looking for the truth. It's either, and it's coming down to three options. It's either, and one of the options isn't favorable, but this is the reality of it, is it's either from the blood, it's either from the vial, it's not Stephen's blood, and they've swapped and done switcheroos. The blood is from the sink, and it's in my opinion, it's a Christmas miracle. I never said it wasn't possible. I said the plausibility of it is lower than everything. Or the last option is Stephen blood in the RAV. There's your options. And
I've started watching Ma'am again, and Stephen's on a phone call to someone, I can't even think now. And he's like, they're talking about the blood, and he's like, they've taken so much blood from me. They like, wasn't that long ago they took blood from me or something like that? And he's really emphasizing on the fact that they've taken blood from him more than once. That's how it come across to me.
And there's that as well. There could be, we talk about the 1996 vial, but for all we know, and I think a lot of people, I think even Mystic Jinx has said in a few podcasts, like he had an operation while he was in prison. Was that stored in a hospital? Is there any alternative vials? It doesn't have to be that vial. It just has to be a vial that contains an EDTA component, because that's what you need to stop the coagulation. So we're all looking at 1996 going, is that the source? Is that the source? We don't know. There could be another source that we just don't know about it, or it could be this simple. And I know Dr. Silkman just stepped away for a minute, but when he does come back, there is another alternative. And the other alternative is it was created in the lab, and it's definitely doable. When he gets back, if we're obviously still going, if he's not already. Are you back, Silkman? No. And then basically you can create that. You just have to have the DNA source. You draw it in, you take all the cells, you separate it, and then you create it. Again, I'll leave that for Dr. Silkman. I'm not going to go into the laboratory side of that.
Right on. But thank you, Kelly. And Denny has I brought up some pictures for comparison. Is that right, Denny? Is that what you wanted me to do?
Yeah, I kind of wanted to bring up some of these pictures, and seeing that Kel has done experiments, and especially like the video that we saw where the flake actually pops. Wanted to pick her brain on some of this pictures that we do have of the RAV. So starting with the one on our screen, this is in the back of the RAV. This is supposedly like hair marks of blood. And I think you had touched on this a little bit ago, Kel, as far as in my opinion, that blood looks like it's been raised. It probably coagulated and dried with hair there. I don't know what.
Yeah, it's a tough one. I think it's pretty hard to see it any other way. That it looks like coagulated blood.
It does look slightly raised compared to the rest.
See if I can zoom in a little for you. I don't know if this is the one. Yeah.
Oh yeah.
It just seems funny to me that when we look at this picture and you see this like this grayish area, right? It's white almost. It's like you see some blood and then you see like the main stain on the left side, right? But like this discoloring of underneath the stains, doesn't it seem strange that right where there is
Yeah,
all
I've
this
always
blood
thought that.
also seems, and
I've
it's it
analysed
does
it.
look tacky, like in some spots that maybe it didn't drop there, and I think that's why, and I tend to agree with the conclusion that this was a contact stain, that this was
Right.
not dripping blood, but that this was smushed together from something potentially Teresa Halbach's head or another part of her body was pushed up against this that had blood on it, and that's creating these marks. Which
She could have been wrapped in something, and that's why there's blood, then no blood, then blood. A tarp or something like that, and it's preventing the blood from hitting that surface. But there's
can
also
see
some
that.
specks. There's sort of a couple of cast-off specks as well above
Sure,
that
certainly.
on the panel, which I found really weird. I wonder how much blood there is there, Kel, like in its whole volume. Considering what you do and how minimal amount you need to make it go so far. I wonder how much is actually even in the back of that rab right there.
In terms of
in a droplet or whatever, in mils, whatever.
Droplet. Now, see, okay, just pause it there, guys. See that little stain up the top, like that little drop that you see above?
Tiny little drop.
Tiny little drop. So on one of my experiments, without even trying, I was able to create that without even realizing. So what had happened was it wasn't with a dropper, it was with the tip of a syringe. As I moved the syringe over the container that I was using to do my experiments, a little bit, the gravity and because of the fluid, it dropped out, so that I was able to create the exact same pattern. What you see now, I have a picture that is identical to that. I'm just not showing it yet. All in time, my precious, all in time.
But if I'm correct in my assumption, the part of the blood that we don't see, that's where they would have taken the swab and dipped in to gather it, correct?
As in the swab, the saline, like they would have used, because he used saline to do the presumptive test.
Yep.
Yeah. So, and if you look properly, you will actually see there is stain. Like you can tell it's been swabbed because of the way it's missing some of the bits.
Yep.
You can see where the tail is and where see that it's hard because I don't have control over this picture, but the picture on the left here where it looks down, that looks like someone has dropped it down. Like that's a 90-degree angle, because when you look at the bottom of the tip, there's like a little ball which you see when it's been a drip and it's kind of gravity's pulled it,
right,
and then it's dried. But this is what I was saying in the podcast and the comments the other day. I can control the patterns by the tip of a syringe or a dropper. As you guys saw, when I show you guys on the video that coagulation clot forms at the base of the dropper, you use that to paint. So you're not adding too much fluid where it's just going to go everywhere, but you're able to create a pattern that you desire. And it comes out liquid. When I try to do it with the Q-tip, as you guys saw, it absorbed in. It didn't, you can't add it. You can take it away with the Q-tip, but it's harder to add that. And you definitely can't create, and I saw a comment saying maybe they used a Q-tip and then added water to it, and then that you saw it. We have actual liquid form stains here. It's not a matter of using to wipe on a stain. They're dripping a stain on. You can't do that with a Q-tip, even with water, because it will just absorb in and take it all in. See what I mean with the lighting? See, this lighting, it's different again. But as you can see, this one is a little bit better because you can see here what I mean by how it goes down and then that that end, the tail. But it's also another interesting thought, because the thought is, when we look back at my video of when I threw the thing at my son's face, bless my cotton socks and his, the tail is at the back of the direction it's going in. So this one doesn't seem like, this one can go in two directions. You can either go, someone dropped that first one from a 90-degree angle from down, so it started to drop down, or if someone flinged their hand up or something up, it's contacted up. That one on the side makes absolutely no fucking sense, period.
No.
At all. I would, if that middle one, that one on the right had been gone, like taken out of it, and they just left that, just that one drop on that 90-degree more angle, that's more believable than that side one, because that side one makes no sense. There's not enough room to fling it from left to right. It's no in direction of a cast off from a hand turning the ignition. That's not the direction you would see it. It's been placed on. It just makes no sense. It's a pattern that is controlled, in my opinion.
Absolutely. Well,
it's very strange. So that's basically
That looks like it's done with the dropper.
It is. The irony of it is, because I've only shown you guys the dropper experiments. In fairness, in my opinion, it's more likely they use a syringe, and that's another conversation for another day because of the patterns. But the dropper, just for the simple fact that the drops that I was able to create authentically and naturally without even trying, as you saw with the dropper, because there's air, you get more air in a dropper versus a syringe, which is designed to not bring in air because you don't want to get air in your veins. When the blood drops out of a dropper, if it's added too much pressure, as Jeff Jones brought up when I showed you guys the bathroom again, when I squirted it out, it kind of squirted, there was more drops created. And that's a part that it's hard to control. Where a syringe, it's a tinier vessel, it's a tinier opening. So when you put the pressure and there's air in it, but a compressed air, it's easier to control. And you just have to have it on the tip, and then you just paint, like you just gently move it around to your desire, to what you need. And it forms in, and the video that I do have, which was, I try to create some experiments of Cuss Road. So I took some of my fresh blood and I went into the dirt, and I went onto the gravel road, and I put some blood in there for some reasons, which I'll address later. And what had happened was, it was me and my daughter, we were at the front of my house. I was out, it's all on video. It is a bit gross, so I don't know if I'll edit this one out, but what happens is I go out there, I explaining on the camera that I've been using my fresh blood for 10 minutes now. I've got about 5 minutes left. I'm at the peaking point. I can see in the syringe that little clots were already forming in the liquid, so I had to get rid of it. And so I walk onto the road. You see me go to squirt some on the road, and it wasn't coming out. I press harder, and it goes everywhere. And you see the clot come out first, and then the liquid follows, but the liquid of my blood goes all over mine and my daughter's legs because it just squirts everywhere. And you hear that's basically why I would have to mute it out, because my daughter starts screaming, going, "Oh my God, that's disgusting." And she made some other very inappropriate comments about my blood. So in a joking form, but just not appropriate for, a live or a podcast. So that was just to show that even in a syringe, it still, everything forms clots. It still coagulates. The funny thing was, though, I wanted to know, like, there was a test I did, which what I just explained to you guys now was, that's fresh blood. So in fresh blood, I had a 15-minute window period, and that was about 5 mils of blood. and I was having to move really quickly. Now I use EDTA blood, and what I had done, I remember it was me, Kath, and Justin on this one, and I don't know if you guys remember this, but remember I took blood out of the EDTA tube, the vial, and I put it into a my dropper and my syringe, and I left it. I left it for 8 hours.
Oh, yeah, I remember that.
You remember that? And then what I did was I came back 8 hours later, picked it up, and then I dropped it on my surfaces to see if it had started coagulating in the syringe and the dropper, and it was still liquid form. So even out of the EDTA, as long as it wasn't exposed to air and it was still in a contained environment, it still didn't coagulate. But the moment I dropped it onto the sink, it took, I'm thinking, another further 3 hours to get to the stage 5 of coagulation, but it still was that's the only way it turned. Whereas in fresh blood, 15 minutes compared to EDTA, and the reason why I did that, because I always thought, when did the blood get into the RAV? When? Was it on the Avery salvage yard? Is it they found the RAV on the 3rd and they had placed it in the RAV and then had the blood already in the RAV and then put it on the salvage yard? Or was it done on the way to the salvage yard when this allegedly disappears for an hour off route? Or did it happen in the lab? Now, the reason why I did the experiment of taking it out of the vial and letting it sit for 8 hours, because I thought, would someone take the vial out of the area and make it completely disappear in the risk factor that what if they couldn't then get it back in? They ran into a problem and then it just disappeared, and then they realized that this vial was missing. So I put it in my dropper to see whether someone could have went in with a syringe, drew some blood up, put the cap on it so it didn't endanger themselves, because that is a risk factor with syringes being pricked. And I have to say that when I did my first week of experiments and I used the syringe, thank God I did use my own blood, because I pricked myself in the process of the experiment. So, and then I thought, if they maybe carried that around with them for a while, and then when they saw the opportunity, they put it in the RAV themselves. And I was able to say that, yeah, when you look at it as that alternative, as an alternative narrative, that is possible. It is plausible and possible as long as EDTA blood. It can be carried around for 8 hours in a method like a applicator, whether it was a dropper, or a syringe, and still be liquid form, where you can't do that with fresh blood.
Kel, I got a question for you with the pic that Jeff has up right now.
Mm-hmm.
You just showed us a video of it was fresh blood and it popped its flake, right?
Mm-hmm.
Now with this surface, would you assume that this drop would have peeled and popped like that?
It could have. This one's a hard one, because we're looking at a year later. This was taken in September of 2006, I believe, this picture, when they went back to the RAV. So it's really hard, because as you can see, there's so much crustaceans have happened. I don't know whether it's a natural flake. I don't know whether it was part of when they swabbed it for their presumptive tests, whether they had removed that part for when they did the testing for whatever. This one's really hard. Different surfaces have different textures, have different results. This one, in my opinion, didn't probably flake off as naturally as what we've seen live. I think this one probably had a bit of maybe an influence to it. That's just my opinion. And the reason why I say that is because it appears like someone has gone in and diluted it at some point because of the texture on the top of it, where someone's had something wet and has swabbed it, because you can see it's broken down. Again, I think that's something that Dr. Silkman would probably like to weigh in on that one as well. I think it's just important to know. It could absolutely be that it flaked off, but again, we're looking at something that is a year old, potentially almost a year old as well. So like the natural side of it, we don't know what it did. And there's no pictures on the looking down to show if there was any excess blood flakes either. So it's really hard.
See, when blood drops as well, it, depending on the angle of the drop, you always follow the tail of the way that the blood's going. So then they can determine which degree of angle of whatever that the blood was splattered. So you can see the thickness at the bottom. So that was dripped and then ran down. I find that a little bit interesting when it comes to the key ignition, because I really don't see a blood going into a whole full half curve and then coagulating
Upward.
at the end there.
Going upward.
Yeah, it doesn't look natural. You know what I mean? So you can see a drop there, it runs down, it coagulates at the bottom and it stops its run. So you can sort of basically work out in your own mind how that was created. But then when you look at the key ignition, you're like, blood doesn't normally do a circle and then run down unless they've started a tiny bit of blood at the beginning and then flicked it up and over. Do you know what I mean?
Right.
I always considered, this is how I considered it, because we have the blood in the RAV. If this is planted and it's not authentic to somebody, I'm not saying Stephen, but just anyone in general, I think they started at the back because that's where the most blood was. And I think as we get through, by the time they get to the ignition, I wouldn't be surprised if that was the leftover blood that they had left and they just kind of used it up in a sense.
Right. Because
I think they would have lost doing that drip if you aren't controlling it to a degree. And I say this out of the experience and the experiment I did the other day with the Q-tip. When you guys don't realize this, man, but when I put that Q-tip in and soaked it up as much as I could and then try to put it on that container, I'm literally going to have to get a new vial. I've got nothing left of it. It soaked up so much, and I'm like, God damn it! And I needed it. They've got enough to keep now, but there's no more I can use experiments with. There's just not enough, and I wanted to keep it because I just want to let it just run its course now, as long as it can, just see what happens. And in fairness, it is kind of destroyed now because there's been so many times I've opened the lid compared to when 1996K vial had been open. There's a lot of inconsistencies now with the vial in terms of accuracy between the two, but it's still, I want to just let it play out. And I think they would have used the majority of their blood that they did have available on that drip that we see in the back. So to me, common sense would be that probably would have been the first place they put it, because they had the question is, why there? Why in that location? And I've always considered that it's because they were trying to tell that story that the seats had to have gone down at one point, because Teresa was found in the back with the seats down. Not my apology. Teresa's blood was found allegedly in the back and the seats were down. If the seats were up when she was there, then they had to show a narrative where at one stage Stephen would have had to have gone in the back to put them down. And I think that's where they've done that. Who that is, I don't know. And here's the problem, and I've definitely said this on a podcast a few times. Here's the contradiction of both sides. We all agree that if that's Teresa's blood, it's very rare. Like it's odd that someone's put the blood everywhere but in the back with her blood, because why not mix the two sources so it looks more authentic? Because if someone's bleeding and there's someone else bleeding and you're moving them around, you're going to cross-contaminate that, right? And a lot of us are always like, well, why isn't Stephen's in the actual blood in the back? And Kathleen says, in her opinion, it's because the cops knew that it wasn't her. They weren't sure if it was her blood. That's why she thinks it was the killer, blah, blah, blah. But what's contradictory of that is the fact that, let's say the killer did put her in the back and he was responsible for putting Stephen's blood in the back or in the car. Well, if they had the knowledge of both sources of where they both come from, why then wouldn't you mix them? So it's like we have a real problem with like diversity here on terms of balance. Like either someone knew both of the sources, or there's two forces at play with one person knew one force of the source and they didn't know the other one, and vice versa. Because if, in my opinion, if you were the killer and you were the one planting the blood, yet you were that sophisticated that you got yourself to a point that you were able to collect blood from the sink, you were able to transport it, you had time on your side, you had the weather conditions on your side, you had all these factors on your side, and the biggest thing you had on your side was the fact that he even bled that night. That wasn't even accountable for in your plan to begin with, and it all just fell in the line. Why would you then not mix the DNA profiles together? Because if you're responsible for her blood being in the back, you know the source of it. So there's a few things that have always tripped me out in terms of, the balance of who did what, where did the planting start, and where did the true crime begin. And I think, in fairness, in the community, that's a struggle that we all constantly have in this case. We all sit there and go, we don't know where it started, where it finished, who picked it up, and who created this narrative. It's one of those unknowns.
Well, I'm with you there on that for sure. Denny, Calf, do you guys have anything to add that you just heard?
No, I would like to thank Kel for sharing all of her results with us.
Yeah, I find them fascinating.
I know there's some more. It'd be nice to see more.
You've
talk
seen
about
them,
more.
Yeah.
Are we going to see a part 2 to this, Kelly?
I'm not sure yet. I'm just going now that let's just see how this all goes.
One,
I think we should kind of like just see how this gets like picked up in the community, see how people are, where they're leaning, whether they want to see more. Leave it to the community to, I think it's fair for them. I guess I can always put it out. It's up to every individual. You don't have to watch it, but there is a lot of work for me to do. So I don't want to have to be doing it if only like 5 people are just curious, because I'm happily could just go on a Discord channel and just open up my computer to everyone and just talk through it without releasing it. And it's a lot less work for me to do in terms of, and as you can see today, this was just, I put some videos together and I haven't prepared this presentation. This is just winging it, of just showing you guys what I've done. When I wanted to do a proper like presentation on this, I wanted more medical feel to it. I wanted it to be really broken down in such a more educational way where everyone can really understand it and get to the really nitty gritty parts of it. Like, I touched base on the medication that Stephen was on. Like, I want to be able to go through all the big factors. And the other thing that I wanted to bring up was like, just, the anatomy of the hand itself, the finger. And that's something that me and the wound itself. And that's another thing that people don't really quite comprehend and take it into a factor, whereas there's a difference between a freshly cut wound versus a wound that has already been crustified and is in a healing process and it gets reopened. There's all these factors, and that's something that I had the advantage of using my expertise in the medical field and getting some medical opinions from the consultants when we sat down and we brought up the anatomy of the finger, and we kind of went through all the veins and the location of his cuts and what it meant for the drips and how much he was bleeding, and the drips we do see and the measurements of that. What is that in terms of the flow of his finger and all these factors? So that's kind of why when I say I want to see how the community takes this is, I don't want to have to do all this. And I know it's good. And even if it reaches 5 people, I'm not complaining that I want this to go global. It's just a lot of work. And I just want to make sure that everyone's on board with it, basically, because I want it to be well done, because everyone in the community deserves a good presentation, a very thorough one that everyone can follow along with. And I think what Denny's more excited was, which is my favorite bit, is the swabs. I have done experiments that show the swabbing of the saline and your presumptive test, and the comparisons between Sherry Colhane's, mine, and EDTA blood versus fresh blood. For me, is that what you were getting? Yeah, that to me that's my turning point in the case. Again, it doesn't give you a conclusion, but it just is very interesting. It kind of, at best, it doesn't give you a conclusion, but for me, it gives us a time period at best, what we're working with. So, yeah, I think Silkman's back.
Yeah, sorry about that. Yeah, I listened to all of that, believe it or not. So what is interesting, and there's a couple of parallel things going on here, which I think we need to address the elephant in the room, and that is the DNA methylation results, right? And I think you pointed out, Kelly, the part of the blood that was used in the DNA methylation analysis was from the cloth in the seat, right? So that's not like a stain that you put on the ignition or the rear door or anything like that. It's actually in the cloth. And if the DNA methylation results are correct, that rules out the blood vial, right? Because the DNA methylation results indicate that the blood wasn't as old as from 1996. It indicated that the blood was more fresher, right? So if that's the case, then the source of the blood, this is where you get all these contradictions. If that's correct, then the source of the blood in that RAV4 can't be from the blood vial, right? And it's the blood vial that's got the EDTA in it, right? So the methylation studies tend to suggest that it's fresh blood, right? So the only fresh blood that I know of is either from the sink, and I reckon we've conclusively ruled out the sink, because that doesn't work, right? Because if you're going to use blood from the sink, it has to be really, really quick, right? Otherwise, it's going to congeal. You're not going to be able to transport it. You need the RAV4 nearby. And I think your experiments elegantly show it's not reconstituted blood from the sink, right? So therefore, if you rule that out, it means that the only fresh blood that was around at that time, think about it, it's either Stephen Avery's finger, or whether he bled from his nose. It's either from Stephen Avery himself. So he was in that RAV. That's one possibility. 2, it's blood from the Pontiac Grand Dam, and somehow they were able to use that blood. I don't know if they got it on another cloth or whatever, something like that. Or it's another swab from either his garage or in his trailer. So if the methylation results are correct, if they're real, that rules out the blood vial. Do you agree?
I agree, and I agree. That's what I brought up before, which when I said there is alternatives here, and one of them's not favourable to Stephen, and that's something that Kathleen's been very vocal about. She feared this. She knew that she had a problem if it comes back fresh. She knew that, because she then has to get people to believe, of judges to believe, that someone planted from a sink, because that's the only, and that's why I get it. That's why I get why she's going there. Although I find it, because of like science and because of physics and what we were able to demonstrate and everything that you've brought forward in terms of your experience with blood and working in labs, it's a bit of a stretch, but I respect her in that is where she has to go with it. And I'm all for it. the problem that I have is if we're able to see this Dr. Silkman, the state, if it ever got to the point where it was a retrial, the state will just bring in experts to say, echo everything we've said in terms of the problem with the sink blood theory. And
what about if they got the blood from the Grand Dam and made up the DNA profile from that, and then just used that on all the swabs that they got from the RAV, and then the blood in the RAV's irrelevant? It could be anyone's.
Kath, you can explain everything except the blood on the fabric piece.
Exactly. That's what I keep going back to, is the fabric piece. That's the problem we got.
I can explain the entire setup, except if that DNA methylation result is correct, it means that the blood had to be fresh. It wasn't from 1996, right? So that now brings in some very interesting angles. How do you explain it, right? How do you explain the fact that the blood can't be from the blood vial, yet if you're going to plant blood, that's what you would use, blood from the blood vial or blood that's got EDTA. I don't know whether Stephen Avery has given blood at any other times apart from 1996, but then it begs the question, how did the planter get access to it? You could understand the blood in the blood vial, right? But any other source of blood now starts to become very, very difficult and interesting to explain. Put it that way.
Yeah. And I think that's my fear in terms of this case moving forward, this is why I always harp on about the blood, because it'll always come back to this moment, the blood in the RAV, because like Dr. Silkman just said, we have a bit of a problem. If this is fresh from Stephen, you can still try to get around all these other little factors like the ignition and the panels, but once you get to that fabric, we've got a new ball game. To
me, I'm telling you, the most important piece of forensic evidence that I've spent all my time really is the RAV4. That's the Rosetta Stone of everything. And I like the way you analyzed about, what's going on here. You've got the blood in the back of the RAV, you've got the blood in the front of the RAV, but you've got no mixtures, right? So hence that tends to indicate that if it's a planting scenario, the person that planted the blood, that's Stephen Avery's, had no idea about the blood, whose blood it belonged at the back, correct? Because otherwise you'll mix it everywhere you want. So the impression one gets looking at that blood in the RAV is that Stephen Avery drove that RAV. Is that the impression you get? You have a look at the distribution of the blood where it is. One tends to indicate that he drove the RAV somewhere, right? But if that's your scenario, it doesn't explain the lack of blood in all the car areas where you would expect to find blood if you're driving that vehicle. And you showed that if you drip the blood on the gear lever shift, you leave an outline, an imprint of where that blood stain was. Even if it fell and formed a flake, around it, you can see the impression of where the blood had dried and desiccated. The RAV4 doesn't make sense.
Yeah, but what about the fabric? It's like T1 said, he said, wait, you can't cut a piece of fabric out of the RAV4 and taint it with the Grand Dam blood? Or why not just swap those two samples around?
Yes, you can. Yes, you can. You can take the piece of fabric from another area of the seat, or furthermore, you don't know. I think Culhane has shown pictures of how much fabric has been cut out. You don't know whether it's an adjacent piece or whatever from the seat that could have been seeded with blood. But as Kellie will point out, how do you convince a judge that that's what happened? Where's your proof?
Exactly. That you're then going through a planting. Then you're then saying it wasn't the killer, it was the lab tech, because they had to have gone back. They had access to both, and they were cutting fabric up. You have to get a judge to then be convinced that the law enforcement or the labs were going around cutting up fabrics, swapping fabrics, planting blood in on fabrics but that's not where Kathleen's going. She's going with Bobby took the blood from the sink and planted the blood. So she's not even touching that. So if they don't believe the blood sink theory, that doesn't lift off the ground, where do you go from that? You can't then just go, well, okay, let's now add this part into it. They're just going to go, fuck off.
Yes.
Yeah,
I think
And by the time they get there, they'll procedurally bar it all anyway.
But didn't her expert must have ran a test of trying to get blood from a sink and then dropping it like you've done?
Okay, so we've done it. So this is okay. I'm glad you brought that up because it's a good reminder. Kathleen, if you go back and watch MAM 2, which we will be getting into MAM 2, and I've got some still screenshot pictures. Kathleen, you got to remember when Kathleen went into this case, she went in there with the idea that she was going to pick up the blood vial narrative and go with that. So majority of all her experiments, everything she uses, you see, it's from a purple top. She uses EDTA with all her experiments, but one. There was one alternative that she finally used fresh blood. And you see it. It was the blood sink. She used EDTA blood on the sink on one frame of the MAM 2, and then on the next one, you see her in like a back. You see her in a different room with the sink, and that is she took it from fresh blood from her paralegal consultant that was sitting there, one of her team members, a male. It's in the report. So she did do what I've done. She compared the two. If you watch MAM 2, the doctor talks about what Dr. Silkman keeps saying is about the time. He kind of drops a few little eggs and basically says he was leaning more towards the EDTA himself because of the time problem. They took the guy's blood, the fresh blood, and they waited 90 minutes to get the desired coagulation stage that they needed to plant to get what they needed or what they desired for. We know that what I've proved to you guys, you can't wait 90 minutes with fresh blood. You just can't, especially if it's coming from the sink and it's from Bobby. So on one breath, she's trying to tell us all that it happened, that Bobby, because when Stephen saw those lights, it was Bobby leaving with his blood. But on her own experiment, she let it go for 90 minutes. So which one is it? Did Bobby wait 90 minutes or did he move immediately? Because you would have to move immediately. I've proven, my apology, I shouldn't say proven, it's not fair because I'm not a scientist, but in my experiments, I've shown alternatives to that it's harder to wait 90 minutes with fresh blood and have liquid form. Would you all agree with that?
I would agree.
Agree?
Yeah.
So we have another contradiction with Kathleen's own experiments that we see on Making a Murderer. 90-minute blood. And the other thing is the reason why I had to be really mindful when I said to you guys, Kathleen done great experiments. She did it, but how controlled was her experiments? The only thing that I can confidently say that she was one up on me was she was using the fucking sink itself. I didn't have that. But I now have to ask her as a person who conducted the experiment, Kathleen, did you consider the time? Did you consider the temperature? Did you consider the other factors? Was the person you took your blood from, was he on any medication? How old was he? All these little factors that, I had to conclude. And again, and the biggest thing was the quantity. How much blood did you actually put in the sink? Did you put enough? You when you watch the experiment, she squeezes it. She was dropping, but a lot of the drops were huge, and she did excessive amounts. What we see, and this is where it comes back to what the consultants helped me understand. What we have document is Stephen's drips, and it's in his bathroom, and it's in the Grand Dam, and they all measured around, I think it was 2 millimeters by 3 millimeters. That's really, really tiny. And the consultant said to me, that is a really good indication because it's showing us a baseline of how much his blood was flowing. And it is in their opinion that he wasn't excessively bleeding. So by the time, and it also goes into the other factor you have to take into consideration is the time and the time of events of narrative. So this is a problem for Stephen because he changes his timeline of events over the years dramatically. And for example, in 2016, in one of his first interviews, he says the events as followed. He was at his ma and pa's having dinner. He saw Andy Colburn. He walked out. He spoke to Andy. Andy and him exchanged conversation. He admitted that he was responsible for having Teresa there. He was being a part of the photography that day on behalf of his sister. We all know how that story goes. He then claims he left Ma Avery's. He went to pull up at his trailer in between, his trailer and his sister's. He unhinged the trailer. He reopened his finger. He then went into his Grand Dam, was dripping, grabbed his phone charger. Chuck rocked up having a big durry out the flatbed truck, waiting for his brother out the front. Durry is Australian terminology for cigarette. He walked around the back of his trailer, allegedly still dripping. Walked in the back, went into his bathroom, drip on the sink, walked out the front and left. That was his timeline of events back in the beginning. In 2016, he says the exact same thing. Then he says, but as he was leaving and they got down the road, in turn, I think he might have even said at the very beginning about the lights, but definitely in 2016, he says, I saw lights, so we went back. We went back to the trailer. We looked around. We couldn't find the source of the lights, so we took off again. And he had the exact same time of events. Add another year and a half on that. In 2017, Kathleen has come into the picture. He changes the time of events. It now goes from very beginning, the same as Andy. He leaves the house. He goes to the trailer. He recuts over his finger. Now he's claiming in this affidavit that he goes while he's still bleeding over to Barb's, talks to Blaine and Bobby and asks them while he's actively bleeding in front of Bobby whether they would like to go to Menards with him. Bobby says, no, I have other things to do. He then leaves there, goes to his Grand Dam, gets his phone charger, still apparently bleeding, dripping, then goes around the back and as follows, goes in, drips on the sink, walks out, same, sees lights. Here's the catch. At the very beginning, he said that the lights he originally saw were RAV lights. In 2017, now that he's at Bobby into now going to Bobby's residence, of the Barb residence, and seeing Bobby, he then changes it to the lights that I saw were not RAVs, they were not police's, they were Bobby's RAVs, Bobby's cars, and he was leaving with my blood. There's another issue you have to now factor in because we've got a timeline of events completely changed to match a narrative that they're going to. You shouldn't have to force the truth. And again, when we look at the blood patterns that we do see, especially on the bathroom floor, the drip that we do have, but if these events do make a difference, because if he's claiming that he did do these events in this order, that would show, because like Dr. Silkman said, your blood would already have been starting to coagulate. All the fibers and all the cells would have started rushing to your wound to stop it bleeding because you don't want to bleed out. So it starts to coagulate. It starts to form that coagulation on the wound itself because otherwise you'll bleed out and die. So I can't see how he's progressively, by the time he gets to the sink, be bleeding worse than when he would have first cut it open. If he's doing all these events in between, by the time he got to the sink and by the proof we see on the floor, it must have been slowed down or just was not that heavily impacted because it was a drip, but it was not flowing. So when Kathleen does her experiments and when I had to do mine, I had to consider these as a factor. How much blood is my drip got really? Because the quantity makes a difference as well. It affects it. The quantity and obviously the quality, whether it's EDTA or fresh, makes a big impact. Apologies if that is a bit technical and that kind of went around in a circle. This is what I was explaining. This is why I want to do a proper podcast where it's more structured. And as I'm talking, pull up all these these documents to show as we go along, so you can follow and see it for yourself with your eyes, with what you see, what he has said, and follow this journey, and then match it with the blood spots that we see. And then the biggest problem that I have is he says when he woke up in the morning, it looked like some of his blood had been cleaned up. He never says that at the beginning. That's not something he adapts to that a bit later. There's actually a phone call when I think it's Pa Avery says to him, "Oh, but the blood wasn't gone or anything." He's like, "Well, no." So, and then later he's like, "But then it looks like some of it's been cleaned up." And by the time he's at now, it's noticeable that someone's cleaned up. The other issue I have with that, we're talking about a man that couldn't even remember he had a fire on the 31st. Yet we're meant to not believe, but we have to trust that his photographic memory of something insignificant like bleeding was something he would remember in detail. I find that hard to believe. What he thought might have been excessive dripping in his head, he doesn't understand how blood dries. For all he knows, it had coagulated and had broken away and fell down the sink and naturally especially like you guys saw with gravity, it might have just dropped off itself and just went into the sink itself and disappeared. These are the factors we all have to consider. This is why I'm struggling to cross that line. I accept, like I said in a few previous podcasts, Kathleen's narratives, she walks me to all the lines and she gets me there. They're great, but I just can't cross them because I find all these variables and all these factors that I struggle with because there is problems with it. Apologies for talking as much as I did.
No, not at all. Go ahead, Dr. Silkman.
I was going to say, look, we need to reproduce those blood results. It's as simple as that, right? We need to reproduce them. Now, I know that Kathleen Zellner was able to do it, but she was able to do it in situ, right? With a blood vial in the RAV, boom, 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 right? But the reality is that blood couldn't have come from the sink, right? Because you don't have the time to do it. Now, I know that Kellie went through about Stephen Avery and his recollections. There's no doubt that he's simply adapting the story one way or another, depending on what Kathleen Zellner's coming up with him, right? So he's changing, chopping and changing. That doesn't help him. The reality is we have to reproduce those results, right? And it's getting trickier. And what concerns me personally are the DNA methylation results, right? Ideally, you want to repeat them again because with DNA methylation results, it's a specialist area and it's where people do like a molecular clock. So basically, the older your DNA is, you have a different degree of methylation. So by using a molecular clock, you can roughly work out how old that DNA sample is in terms of years. Is it 100% accurate? Yeah, I'm sure there's a little bit of leeway, but the evidence tends to suggest that the DNA could not have been from a 1996 blood vial, right? It indicates that it's much more fresher, right? So that's a bit of a worry if the blood is much more fresher, which means that it limits you to the sources of blood that's potentially available.
How fresh are we talking?
Well, we're talking about the age of Stephen Avery, someone around about the age of Stephen Avery, when he was in 2005, rather when Stephen Avery was younger in 1996, right?
Mm-hmm.
So potentially meant that if Stephen Avery wasn't the killer would have been roughly around the age of Stephen, right?
Yeah.
If the DNA methylation results are correct. The thing that gives me great heart per se and doesn't make a lot of sense is that we know that there's another blood sample on that RAV4, and that's A23. So the way you need to really make sure that everything is correct is you need to re-extract the DNA from that blood and make sure that it does belong to Stephen Avery, and not the killer himself or whoever, right? So there is another DNA sample in that RAV4. It's A23. We don't know who it belongs to. So is all the blood you see in that RAV4 from the same person who left A23? And by doing switcheroos, you can easily say, oh, yeah, it belongs to Stephen Avery. But you could have done that by easily swapping swabs.
Yeah, it just doesn't look natural. What's planted in the RAV, supposedly planted, doesn't look natural to me. The only natural blood in there looks like Teresa's to me. All the rest just is sporadically put.
Correct.
To make it look like Stephen was moving around in the car.
Correct. But we need to explain that.
Right? But I think A23 might be legit.
Yes, it is legit. And Sharik Cohen didn't re-extract it, didn't want to know anything about it. But that's interesting because where that blood is exactly on the door latch where you open up the door to put in Teresa Horbach in her RAV4 and then close the door. So not only is there blood, but there's also prints. And no one knows who those prints belong to. So what I'm saying is that Kellie's experiments are excellent, but it doesn't help. It doesn't help clear the picture totally. It's still very much up in the air and controversial.
I still believe that it couldn't have come from the sink because, like, unless you've got the RAV parked right outside Stephen's, right there when he actually bled, it's undoable. Like Kellie's proven that you can't water it down, you can't take it away, water it down, put it in the RAV later. You know, it coagulates. It's a shit show. It's undoable.
And as Kellie pointed out when she spoke with Investigator T, there's a risk of you leaving your DNA in that RAV4 every time you go in there. Right. And remember, Bobby Dassey was asked by the detectives, are we going to find your DNA in there? Are we going to find your fingerprints in there? He straight out said, no, I was nowhere near the RAV. Right. So that's a big risk to take if you're going to plant. Right. So I would rule out the sink theory. I think that's dead and buried. Right. But to me, the real worry, I can explain the EDTA, but I can't explain the DNA methylation because it means that the blood was relatively fresh, right? And it can't be from the 1996 blood vial when Stephen was much younger, right? So there are dilemmas. There are indeed dilemmas.
Well, why don't we hit this question that's been sitting up there for a bit, and that's can you tell the age of blood, the difference, I guess is what they're saying, between a newborn and a 90-year-old person? Or could you tell a difference between someone from a 10-year-old and a 12-year-old and a 15-year-old and I believe that the new testing does actually demonstrate that. Is that correct?
Yes. So what they do in a specialized laboratory, this is not a technique that you routinely do. There's only a few laboratories that do the DNA methylation analysis. So what they do is they do what's known as a molecular clock, and they look for DNA methylation patterns. DNA methylation is normal. So what happens is that over time, there are enzymes in our nuclei that add methyl groups, they're chemical groups to the DNA. That's normal. So you can actually measure the amount of those methyl groups on the DNA. So they draw up a molecular clock. Then they look at your sample, right? They look at the degree of methylation. Then they go up the chart and say, oh, someone with this degree of methylation must be this old, plus or minus, right? So clearly, someone who's very young would have little methylation because their DNA is not that old. As you get older, your DNA is older, right? So therefore, your methylation pattern as you age differs. But you need a specialized laboratory to do those techniques. That's very different to carbon-14 dating, right? It's a different thing. So they should, and I'm confident they can tell the difference between a newborn DNA and someone who's much older. The methylation patterns will be different. Correct.
Thank you. And then I think there was a follow-up to that question, actually. Did I think you probably covered it, but even if the blood is 12-year-old blood soaked in a car seat cloth, well, I guess what they're saying is, like, does that pattern stay? Does it degrade over time? Is that
well the thing is, right, that blood can't be from the vial that's on the cloth, right? Because knowing Stephen's age, it matched to him being older, not younger, right? So you can't use, it's not blood. It's highly unlikely blood from the vial that's on the seat cover, right? So that's a bit of a worry. The methylation is a bit of.
Can we do a lightning round here? It seems like it's. I got another one. If you guys want to take it, does blood still age in a vial?
Well, the thing is that the when you have the blood, remember, the blood itself, red blood cells don't have a nucleus. It's the white blood cells, right? And the white blood cells in blood, they're not going to divide because basically they're out of your body. So they're almost like frozen in time, right? Because they're no longer in your body. You age as you grow older, right? But when you take blood out back then, you store it in a solution. So therefore, it's almost like frozen in time, right? It's not going to keep on aging because that way you can't do DNA methylation analysis. Then you can't tell whether it was from 1996 or 2005. So the blood, when you take it out of your body, it's sort of like frozen in time. Those cells are frozen because they're no longer in your body. They're no longer receiving the nutrition, the oxygen. They're basically going to die and be frozen at that time point. Correct. Whereas cells in your body now, they're being turned over all the time because they've got oxygen, nutrients, etc., etc. So it's a living system. In a tube, it's in vitro, in glass. It's no longer in the human body.
Awesome. Whew. Well, it's at 2 hours and 51 minutes and 23 seconds. So we really packed it in there. It seems like that's what we do when we do these lives. They end up turning into marathons. So I'm going to hit that part. If you guys have anything else that you're dying to get out, you want to hit, or anything you want to tease for the future, or anything you want to talk about right now, we'll just kind of wrap it up for this live. So maybe we'll leave Kellie for the end, and we'll start with Calf. How about that?
All right. Yeah, I just wanted to say thanks and keep up the good work, really. I don't know, I just find it all really fascinating. I love ruling out a lot of stuff. You know what I mean? Like,
yeah.
I just like ruling out what I've thought in the past or may not have thought or whatever. I'm just learning to understand it all. If you get what I mean.
I do. Yeah, very good point.
Yeah.
Absolutely.
It's just good to just eliminate.
Right. It makes it gives you a clearer understanding, and that's really what we're trying to do.
Yeah,
right?
yeah, it's really informative. It's great.
Denny?
I'm just happy to be back, able to chat with you guys. And had some crazy weeks around here, so I've missed some stuff. I've really enjoyed chatting with all of you. I'm very happy Kel's able to start showing some of what she's done because we've talked about it in the past. So thank you, Kellie, for sharing with us.
All right. And Dr. Silkman, we just heard from you, but you probably got something to wrap up and tease us for your... Does your podcast have one more episode, or is there still two more, or are you going to stretch it out to...
Oh, you mean my reading with Uncle Ken?
Reading with Uncle Ken, that's right.
We got probably about 2 or 3 more, I would say.
All right. I heard 2 or 3 more, I think a couple of weeks ago.
Correct. The once we get started, we get a lot of questions in chat, like we
You
do
don't
here.
say.
And then we get controversy and a lot of topics, and we get sidetracked. But yeah, it's a learning experience. But personally, just to be quick, I want to thank Kellie for doing the scientific analysis and studies. You learn. That's the whole idea. You mustn't keep any hypothesis or theories close to your chest. You talk about it. You discuss it wherever it may land. And there's some really uncomfortable questions that we've got to ask, right? And you mustn't be blindsided with what Kathleen Zellner is trying to achieve and do. You do it independent. You do independent analysis, independent studies, right? And to explain the blood and the RAV is not an easy thing to do, right? And that's the whole purpose of doing these experiments. And as Kath said, what's more plausible? What's less likely? What's more likely? And that way, eventually, you get to the truth. And that's what we're all striving for. Thank you.
Well, thank you, Dr. Silkman. And Kel, appropriately, you get the last word today. And usual, I think.
That's the usual. I was just thinking to myself, do I really want to talk? I think I've talked enough. But anyway, I just want to thank you guys for allowing me to, again, show my experiments. Hats off to you, Jeff Jones, for giving me a platform to do it. And yeah, I just, again, my disclaimer is really simple. I'm not here to change anyone's mind. I do not have conclusions. Sometimes the irony is the more I present, the more questions we're having. That kind of also runs us into a bit of a dilemma, because then we are like, shit, I felt like I was, 2 steps forward. Now I'm 10 steps back because you've got me. People say to me, you've got me thinking, taking it back to the beginning again and what it all means. But that's what we have to do. We're not, again, I'm very aware and conscious that I'm not going to come up with the solution or the answers, but at best we learn together. We challenge each other in healthy ways. We give each other, encouragement, and that's what I feel like I'm getting here. You guys have all been encouraging this, and it feels good. It feels like my efforts, me going extremely anemic, on behalf of these experiments were worth it. But yeah, I just want to thank you guys for allowing me to do it. Again, I wish to God it got us a little bit step closer to releasing the boys. I wish it got us a little bit step closer to knowing what actually happened. But I'll take what we have, and that's just a basic understanding. And thank you.
All right. Well, that's, as they say, a wrap. Just a tremendous podcast. Thanks to everybody involved. A special thanks to Kellie again. Thanks to the additional members that popped in, Denny and Calf, that helped shore up and keep things moving. And so from everybody here discussing a murderer, this has been a Discussing a Murder Extra, discussing the blood.